அந்த அளவுக்கு நல்லா என்கேஜா போயிடுச்சு. ஆமா சார்.
Good evening, everyone. On behalf of our Atal Fdp team, I invite Professor R. Pradap, convener and head of the Department Mechanical Engineering, to welcome our chief guest and participants.
Good evening, all. On behalf of the organizers and the faculty development team, I have a warm welcome to Dr. T. Shekhar, Head of Department, PG Manufacturing, Mechanical Engineering Department, Government College of Technology, Coimbatore, for Day 4, Session 1 of the AICTE Atal-sponsored online faculty development program on Advanced Manufacturing and Industry 4.0. We are honored to have you discuss to present and future trends of Industry 4.0. Your expertise will provide a valuable insights into the latest developments and future directions of Industry 4.0. Thank you for sharing your knowledge with us. We look forward to your informative session, and we welcome also all the participants for the session day 1 of day 4. Welcome you all. Thank you.
Now I welcome Dr. A. Faizur Rahman to welcome the chief guest.
Good evening, participants. We are delighted to welcome Professor Dr. T. Shekhar, Head of PG Manufacturing Engineering, Department of Mechanical Engineering at Government College of Technology, Coimbatore. With more than 27 years of rich experience spanning teaching, research, industry, and administration, Dr. Shekhar has made remarkable contributions in the field of manufacturing, materials, and advanced manufacturing processes. He holds a PhD in Mechanical Engineering from Anna University in 2009, and he is a gold medalist in ME Manufacturing Engineering on 1999 from Annamalai University. Dr. Shekhar completed his bachelor's degree in Mechanical Engineering from PIC College of Technology, Coimbatore on 1997. He is a chartered engineer in Institution of Mechanical Engineer, UK, and a senior member of INAE. He got industrial safety certification from NEBOS. He completed his MBA in Human Resources from Periyar University, Salem on 2014. He has also trained at IIT Hyderabad in 3D printing and design services. Dr. Shekhar has published over 83 international journal papers, 2 national papers, 89 international conferences, 40 national conferences, 4 books authored, 2 book chapter published, 65 projects guided for UG and PG students, 5 PhD guided, and 6 PhD guidance under progress, 9 design patents, and 3 patents under examination. Alongside his academic achievements, Dr. Shekhar has provided valuable administrative leadership as examinations in charge, Board of Governing Council member for Nehru Institute of Technology, Coimbatore, Program Officer, NSS Unit, Editorial Board Advisory Member for Journal of Engineering, Science and Technology, Taylor's University, Malaysia, and IPR Cell Coordinator at GCT. His research spans electrochemical machining, EDM, friction stir welding, composites, additive manufacturing, and AI/ML optimization techniques. He got memberships in various bodies like INAE, FIE, MISTE, MIIPE, MMRSI, and IMEC UK. With this expertise, vision, and dedication to innovation, Dr. Shekhar continues to inspire students, researchers, and industry professionals alike. We are honored to have Professor Dr. T. Shekhar with us today. I welcome you, sir, for the session.
Thank you. Thank you so much. So good evening to all of you. So it's my great pleasure in joining with you with the future pillars of the expected developed India 2047. And formally, I thanks to the management, the principal, and the faculty development program team members, which is sponsored by Atal on advanced manufacturing and industry 4.0. So thank you so much. So for meeting with the young peer groups. So today we would like to have a discussion on present and future trends of industry 4.0. So actually the devised scheme is, so first up to 7:15 we would like to have a presentation, then remaining the last 15 minutes we would have a fruitful interactive discussions. And the expected outcomes of this presentation is you have to guide your students through offering the mini projects with the help of the available sensors as well as with the help of the AI technology. So within this word, I would like to go for the furthermore uh, content of the today presentation. I devised my presentation in the way of introduction. Second thing, what about the industrial revolution? So what are the various kind of industrial revolutions already covered? And what about the necessity for discussing about the industry 4.0 as of now? And what about the key elements of industry 4.0 as of now? And how do we show our knowledge over the improvement of the existing industry 4.0? What about the impacts of industry 4.0 among the students community, among the industrial community, and among the societal well-being? In what way the industry 4.0 contributed, and what kind of the so future might be? So definitely there is no 4.0 as of now. The 5.0 is nourishing up. Then what about the 6.0 and beyond? So is it possible to have a industry 7.0 or not? What are the challenges and what are the limitations or constraints behind the future expectation and conclusions? So here the industry 4.0, the word is actually coined by German government very long back, 2011, in the conference conducted at Hanover. So one of the largest trade fair for industrial transformation, innovation, and development. So that word is widespreadly accepted by the industrial community by the way of taking the charge of World Economic Forum in the year of 2060. So 2060, now 2025, still we are talking about the industry 4.0. Just imagine the impact on the industrial side as well as the employment market. And here the basic thought behind the industry 4.0 is digital transformation. We might be knowing about the analog as well as the digital, but here digital transform manufacturing and promote the concept of interconnected smart factories with the help of cyber physical system, that is obviously abbreviated as a CPS. But before going to knock the door of industry 4.0, we need to have a brief view about what about the industry 1.0. So here actually started with the 18th century, late 18th century. So mechanization of production using water and steam power. So the steam engine. So the human effort, so maybe replaced, partially replaced with the help of the steam power. So that is the basic knot behind the revolution that will be that actually coined as a industry 4.1. So we have been taught about the steam engine was invented by James Watt, but the real story behind that actually the Thomas Savery. So in the year of 1698, actually he himself created a device with the help of the steam power application to pump out the water from the mines. So that is the first. But what about the future of the Thomas Savery engine? There is no moving part. But the furthermore development by the way of introducing the moving part, in case of the steam engine, that was done by Thomas Newcomen. Then the Thomas Newcomen engine has been modified by the James Watt in the year of 1765. That is the real patent engine, steam engine. So that is the reason behind we obviously called the steam engine inventor is a James Watt. So these are the quite well-known picture for you. So those days, the commuting purpose by the way of only the bullet cart or by the way of the pedestrian activities. But after invention of the steam engine, the migration. The left side diagram is a Thomas Savery engine with the help of the pressure difference. So absolutely the application of the Bernoullis, right? But I don't know exactly about whether the Bernoullis is invented that principle, but the principles of difference in pressure we have been teaching to our students community, that the simple manometer or differential manometer, right? So that is a difference of pressure. With the help of the difference of pressure alone, so to pumping out the water from the mines, that is the first device actually utilized with the help of the steam power. The second one is with moving part, that is a Thomas Newcomen invented engine. So with the help of the steam power. But industry 2.0 by the way of invention of the induction motor. So what about the beauty behind the induction of the induction motor? First one is the DC, direct current induction motor. Then only the alternate current induction motor was commercially available. And another very important thing is the society is trying to utilize the gas and oil for running the machineries. So that is a mechanical energy converted into some other way of useful forms. So here the transformation actually happened in between the 1870 and 20th century. But another very important thing at the time of the Industrial Revolution 2.0 is a mass production. So thanks to Henry Ford, so he himself introduced first the coined as well as utilized the concept of mass production. Then in case after incorporate the assembly line, that is the mass production concept, the overall product cost would started for getting down. So the reason behind the industry revolution 2.0 by the way of number one is a motor, electricity motor, electrical motor, and second one is a internal combustion engine. First one is a external combustion engine, is a steam engine. Second one is a internal combustion engine. As of now, so we have the power sources either electric motor or another one is a internal combustion engine. As of now, we have the major resources of energy conversion from the mechanical into useful output by the way of these two things alone. And the first one is a motor and second one is a internal combustion engine. And thanks to Michael Faraday, 1821 created the first electromagnetic motor, but without getting the patent. But in case of the first patent was Thomas Davenport in the year of 1837. So obtained designed the DC induction motor. And Nikola Tesla 1887 only the AC induction alternate current induction motor is would be playing a vital role for making the revolutions. So especially in the city of cotton city of Coimbatore. So thanks to first personality G.D. Naidu. So he along with his friend so Balasundaram started that is a founder director of the text tool as well as renamed as a Lakshmi Mission Tools LMW. So here the second person Balasundaram did his undergraduation at UK University in the field of electrical engineering, but fortunately our Ayya G.D. Naidu is only the school dropout. But in India, first introduced indigenously developed induction motor by the credential goes to these two personalities. At this junction, we recall their dedication for the development achieved, especially for the development of India. And yes, as usual, you might be knowing about the auto cycle. That name is the inventor name is Nicholas Atto, and second one is Rudolf Diesel. So they are the master contributors for development of the gasoline engine as well as the diesel engine. So industry 3.0, the basic reason behind that introduction or invention of the transistor. So before that, so we don't have the transistor technology. We might be studied about the school books that PNP or NPN, but the first transistor was invented by the Nokia, that is the Bell Laboratory in the year of 1947. But wherever we want to discuss, we have to have a discussion about the transistor. We need to recall the law name is the Moore's law. What about the Moore's law says that number of transistor on a microchip doubles about every 2 years. But is it possible to alive as of now? The answer is not absolutely yes, but the year of duration is keep on increasing instead of 2 to 4. Reason is yes, now we are started for to produce the transistors in the size of 2 to 3 nanometer size, right? So thanks to the government of India, now so many number of semiconductor manufacturing plants are started, and Vikram, the first chip name is Vikram. So recently released by the government of India, but the size is very close to 10 nanometer. But now Taiwan Semiconductor Manufacturing Company, the TSMC, Samsung and Intel, they are the pioneers for producing the transistors. Now, not in terms of million, billion of transistor would be assembled within the specified space. So now the Moore's law is slowly lengthy from the 2 to 3 to 4 years for doubling of the size. So, but in case of the less than nanometer, what will happen? Quantum tunneling effect as well as the heat dissipation become the severe issues. What about the message I would like to convey to my fellow faculty members? You try to inculcate or try to disseminate the quantum tunneling effect. So what is the real meaning of quantum tunneling effect, and what are the effective methodologies to adapt for completely or partially evacuation of the heat generated during the working of processor into the ambient condition? If the prompt dissipation, heat dissipation from the assembly, microchip assembly, or in case of find out the feasible solution, or at least try to attempt to address the solution for quantum tunneling effect. So these are the hot cake for research area as of now. Most of the prominent institutions located in the blue planet, right? So most of the foreign universities now they have to do the exhaustive research over the quantum tunneling effect. You try to understand about the quantum tunneling effect as well as the what are the effective methodologies are possible to adapt to evacuate the heat, so which would be generated by the way of working of the processors. So we would like to directly come to the main course, that is what about the industry 4.0 and what are the components, essential components usually involved for the industry 4.0. But the basic question arises that is it possible to imply over the small scale? You might be knowing about the micro, small, medium enterprises, MSME. Is it possible to incorporate the industry 4.0 over the smaller segment of industries? The answer is yes, because once we could completely understand about the industry 4.0 concept, so it will be very easy. It is not so easy, but it will be very effective outcome measures you can obtain once you applied the concept of industry 4.0 into the small as well as the medium size enterprises than that of the micro level. So what about the basic element and major element playing vital role in case of the industry 4.0? As usual, you might be very well about the additive manufacturing. In former days, we could call as a rapid prototyping technology for making the prototypes. So we could use the stereolithography. Here also, we have been promptly utilizing the stereolithography apparatus, SLA technique. But so many number of newer technologies so now playing a key role for making any kind of, there is no restriction behind the material selection. Now we have been working on ceramic. So the 3D printing machines for ceramic materials, engineered ceramics, not engineering ceramics, engineered ceramics. Now the filament which has been promptly utilized for the furnaces, that also made by using the additive manufacturing technology. So you try to understand about the power, that is the power of the additive manufacturing technology for making the future employment market or for the purpose of making the entrepreneurships. I mean the students might be inculcated to initiate the startup concerns. So now India is going to touch with the top 10 positions. So many number of startups, once you compare with the 2014. Yeah, yesterday report says that yes, we are marching towards to reach the top 10 position. So many number of startup companies are so now have been started for their operations. So many number of government supports as well as measures are incorporated behind the startup. You try to convey the fruitful message to the students community. What about the basic salient future of the additive manufacturing? Absolutely, there is no reworks. Number one. Number two, there is no issues arise in case of assembly. So you might be knowing very well about the true positional tolerance, right? So because of once you apply the true positional tolerance, what will happen? Each and every component, it has its own datum. If the combination of so many number of components assembled together, the datum is playing a key role for ensuring the performance of the assembled part. But here, absolutely there is no issue. So many any kind of high end of complexity jobs that should be made with the help of additive manufacturing within the single integrated assembly. Single integrated assembly means whatever the clearance you want to given into the assembly, you can do it. Best example, stapler, right? So in case of the stapler itself, it has so many number of components. So minimum of 20 to 25 components. So in case of the stapler, is supposed to be made by using the 3D printing technology. What about the superior advantage? Number one is life expectancy, and second one is the weight of the component. So once you expected the very good life expectancy, I mean the life of the assembly, and the second one is the lightweight, and third one is absolutely very minimal friction would be placed in case of the adjacent parts available in the assembly that requires the minimum force to operate the required operations with the help of the assembly. So these are the salient features of the additive manufacturing technology. So there are the two different, one is subtractive manufacturing and another one is additive manufacturing. In case of the subtractive manufacturing is the so removal of additional excess materials from the workpiece. Here we have to supply the materials for making the component with the help of the filaments. So yeah, these are the best examples for the purpose of understanding about the additive manufacturing for your students community. So making the basket or so making the idiyappam, these are the for making a murukku, right? These are the best example for so the technology behind the additive manufacturing. Suppose if you are going to procure a chapel or shoe from the available market, absolutely there is no chances for exactly fit for your requirement, right? So the same thing applicable for the shirts or pant. So they are having only the standard components, standardized components. So suppose in case of the shoe or chapel, in terms of the British numbers, right? So 6 or 7 or 8. Suppose if you have your foot length is 7.2, is it possible to procure a specific? Answer is absolutely no, because so we are the valuable customers, but we have been forced or we are forced to procure only the available sized components from the commercial market. The basic question raised from the customer side is, why should I have only the exactly 7.2. Is it possible to produce a exclusive shoe for my size? Then the additive manufacturing is ready to address the problems encountered by the accessing with the customer market. If you have a 7.25, then immediately we can make it the shoe with the help of the 3D printing technology. 3D printing pen is available. So now commercially available. These are the salient points behind the additive manufacturing. And the digital twin technology, right? You might be knowing about the digital twinning or digital twin technology. Absolutely, the simulation. No need to make it a prototype as of now. No need of prototype. So the what about the exact prototype to be converted into the simulation? So the real situation or real environment would be placed over the simulation domain. Then whatever the challenges actually expected while operating that equipment, everything would be easily found by the team. Then they are ready to address spontaneously. No need to wait for the time period for receiving the customer feedback after releasing the product into the commercial market. So thanks to digital twinning technology, that digital twinning also expect some part and parcel of the help from the 3D printing technology. Yes, the third one is goes for the jewelry shop, right? So in olden days, the difference between the modern and as well as the old, right? Now less than a gram ornaments might be making in and around of the city of Coimbatore, right? What about the weight? Less than a gram. Now they are producing with milligram weight. But just imagine the surface area. But what about the volume is very less, but surface area is very higher. So, but with the lesser weight, that would be playing a master role for ornaments too. Another one, 2021 itself, the artificial eye, so infused camera eye printed. So in the yes, you just look at that, reveal the Moorfields Eye Hospital. So 3D printed eyes. So but now with the help of the generic AI, no need of such kind of the devices, right? You might be knowing about the Google Lens, Google Glass, and now the so many number of smart glasses are available. But in the year of 2021, EAM is a major role. But as of now, no need to wait for producing such kind of the components for making the artificial eye. Now we have completely so relied over the smart glass concept. What is a smart glass? Let us see in the forthcoming slides. In case of the additive manufacturing, so many number of technologies are available, right? But in the former days, we have to have a very good idea about only three. One is a SLA, so stereo lithography apparatus, and second one is a FDM, so fused deposition modeling, or the another name is called as a triple F. So fused fabrication, right? Filament fused fabrication, that is the alternate word for the FDM. And third one is the so 3D printing. So 3D printing is the commercial name for making the component with the help of the powders, right? With the help of the binders mixed with the powders, then you have to make whatever the products actually you want. But now so many number of advances are keep on racing over the domain of 3D printing. Now we have the direct energy deposition, DED, for making the metal or metal alloys. So here, what about the beauty? So there is no issue for melting point. There is no issue for solidification shrinkages. There is no issue for allowances, right? Everything perfectly we can. As of now, commercially available DED, direct energy deposition technique. So that is the metal additive printers. So here the line 6 direct energy deposition. And in case of the sheet like material, the sheet lamination, laminated object manufacturing, LOM, right? So these are the various. So here this is a stereo lithography apparatus. So photosensitive polymers, based on the photosensitive polymers, whatever the shape we want to make it a component, by the way of applying the UV rays or by the way of applying the laser light, then the spontaneous hardening takes place wherever the laser or UV rays hit over the polymers. Whatever the complicated shape you want to make it, yes, you can do it in case of stereo lithography. But what about the problem associated with the SLA? You have to completely rely on only the type of polymer which is being supplied by the industries. Any other polymers can we use it? Answer is as of now, no. So each and every one now acting as a monopoly. Then whatever the, yes, once you look at the Amazon, so many number of machines are available, but the problem is directly associated with the procurement of the SLA is you have to get it only the types of polymer which is being supplied by the supplier, that polymer alone, right? So anything other polymers can we directly use it? The answer is so. What about the material jetting? Different colors. In case of the FDM fused deposition modeling, so we have to have only the one color, right? Suppose if you have here two different kinds of jet, then only the multiple color. But in case of if you need a multiple color over the component, then material jetting is giving the fruitful solutions. These are the components made by the 3D printing with the help of the material jetting concept, and this is a direct energy deposition. Yeah, the solidified materials started for flowing out with the help of the coding or the file format. Like as a welding, right? You might be knowing very well about the manual metal arc welding. Suppose in case of the multi-pass, what about the problems related to multi-pass? The same welder, experienced welder alone can do the same velocity of the movement, right? If the velocity of movement of the welder differed from the pass to pass, that would induce the stress. That is, the stress might be playing a key role at the time of analyzing the failure of the welded component. But in case of the DED, same pass, same speed, same deposition rate, same layer thickness, same solidification time. So absolutely the rate of failure will be very, very less than that of the conventional methodologies. Now the 3D printing technology, so playing a major role for repairing application as well as so making the small size components for the space vehicle. Yes, here the double seat car, 3D printed RB car. So what about the price? The price is not so, I'm not supposed to say the not so expensive, but as of now, it is not the affordable one. But in case of the future, because of the material, because of the currently available technology, might be giving a tough fight, especially for dealing about that whether cost effective or not. But in future, the 3D printing technology. In case of the Israel, now they started for making the dosa, making of the burger, making of the vada. So everything perfectly being done by only the 3D printing technology. So suppose at your leisure time, you try to check with the 3D printed dosa or 3D printed burger, then you can easily get it some the fruitful ideas behind the importance of the technology. Especially after 3 or 4 years, now the TV is a mandate for all kind of the household, right? Iron box, washing machine, and refrigerator. These are the AC. These are the quite common and essential elements for the household. But the same thing applicable to the 3D printing machine. So the every household definitely I would expect that we would expect that one 3D printing machine is available. So that is directly connected with the cloud. Suppose whatever the things you want to get it, so immediately you just type it the code, then the machine automatically get the data from the cloud and started for producing whatever the things you would expect from the machine. That kind of the things are expected very soon, not only in United States of America, we would expect at India, right? So with the help of our future pillars. So on the second important element behind the industry 4.0 is autonomous robot. So in case of the autonomous robot, so before going to knock the door of the autonomous robot, we need to know about the Muller teacher, right? Muller teacher is one of the well-known autonomous robo, and now teaching the high-end critical subjects to the students community at Anna University. So machine algorithmic learning autonomous robot, right? So that was developed by AI startup Heavy in association with the IIT Research Park. Then the first robot teacher, autonomous robot teacher, would explain about. So one of the biggest challenge, especially for our teaching community, is if we are handling about the theoretical subject, so easy to get the pass percentage. But in case of problematic paper, especially those who are involved in the thermal engineering domain, right? Heat and mass transfer, lot of failures. Design of machine elements, lot of failures. So suppose in case of the human being faculty members, maybe in future would directly be replaced by autonomous robot. So many number of without any fed up or without having any fatigue, how many number of teach the same concept, the autonomous robot never say deny to teach. So many number of multiple number of times to teach, because we have a fast learner, we have a slow learner, we have a intermediate between, right? So usually the pass percentage is purely depends upon the students compositions of a particular class. So in future, I don't know exactly, the faculty role would part and partial may be replaced by autonomous robot that was actually already implemented in the Republic of Public China, RPA. So here the National Medical Licensing Examination cleared by CIOE, a robot, right? AI robot, generic AI now is quite common. But in case of in the Blue Planet, there are 3 examinations to be categorized as a very toughest examination. Number 1, getting the graduation seat from China. Second one is clearing the UPSC examination. Third toughest examination is clearing the advanced JEE examination. Now the ZIOA cleared the National Medical Licensing Examination means you try to think about, so the AI generic influential behind the observed experience or observed the performance of a robot. So many number of computations happening inside the processor, only there will be a chances for getting the clearance. Just imagine, we might be knowing about the CES, right? In case of the CES, so many number of robots, we made it a tough fight. A human being made a tough fight, including the Vishwanathan Anand also made a tough fight with the AI based, not AI based, that is a machine, right? But now the Sophia, yes. What about the importance behind the Sophia? Sophia, the robot, social humanoid robot by Hanson Robotics, that got citizenship from the Kingdom of Saudi Arabia. In the world, the first robot got the citizenship. So that was given by the government of Kingdom of Saudi Arabia. This is a last week news. Just imagine. So what about the roles and responsibility of robot in our human being day life activities? So the robot name is Amica, the most advanced humanoid robot. Yes, thanks to Shankar too, right? The director Shankar. So you might be having the idea behind that. So what are the human being activities that should be replica? Yes, look at. Yes, you just type it about the term Ameca, AMECA, the world most advanced humanoid robot. And what about the other autonomous based robots? Yes, for in case of hazardous environment or in case of warehouse applications, yes, the Amazon, none other than the Amazon deployed so many number of autonomous robot for categorization of the product, classification of the products, and the pick and place type of mechanism behind the warehouse. So Amazon is the pioneer for utilizing the autonomous robot for their day-to-day activities. But yeah, this is a best example for the autonomous robot. Yeah, cleaning robot is also categorized under the autonomous robot. In future, absolutely the housemaid, what about the, these are might be extincting categories. So there is no housemaid or there is no plumber or there is no lower level technicians requirement for the forthcoming expected futures, right? Everything to be done with the help of autonomous robot or humanoid robots. So what about the thing behind the figure? LiDAR, light detection and ranging. So yes, you might be knowing about the ADAS, right? Automatic driver assisting system. ADAS 1, 2, and now only a fewer vehicles adopted the ADAS 3. So ADAS 4, not yet. ADAS 5, not yet. So in case of the ADAS 3, so almost 70 to 75 percentage of routine operations to be done by only the pre-programmed tailor-made programs, and remaining 25 percentage only expected for the driver interventions. But in case of the Google car, right, you know very well about the Google car, but so still so many number of challenges because of the latency rate, that is absolutely called as a remote terminal unit. So what about the information received from the workplace or from the existing environment on the decision making the body? So the what about the difference between the time delay is absolutely called as a latency rate, that is absolutely playing a master role, especially for 1G, 2G, 3G, 4G and 5G, right? So we have been enjoying now 5G. Best example to understand about the latency, what about the seconds required to download a movie, high definition movie, HD movie. Once you compare with the 4G in terms of minutes or hours, but in case of 3G, hours together, in case of 2G, days together. So that is the philosophy behind the importance of the latency, especially in case of the auto decision making bodies in case of the industry 4.0. Yes, the cleaning AI powered robot sweeper. So many number of sensors, detection unit, charging unit, decision making unit, navigation and mapping. So second one is the autonomous, yes, mobile robots. Yeah, the same thing. Yes, humanoid robot, and no need to go for the furthermore about the autonomous level, but try to keep in your mind, my fellow guys. So the part and parcel of the generic AI, in what way that would affect the day-to-day life activities of a common man. So we have to think about the common people, in what way they would influenced by the generic AI. Normally, the selection of autonomous robot based on, as you know very well about the autonomy level. And the second thing is, yes, the SLAM means simultaneous localization mapping, mobility, environment, and so many number of factors are behind. I don't likely to go into the further way. But the thing is, we need to understand about RTK. So in case of here, the RTK is a real-time kinematics. So we taught the subject of robotics by the way of inverse kinematics and forward kinematics, right? So here the new terminology RTK, real-time kinematics. And suppose if the robot identified some obstacles at the time of its own path, pre-planned path, what will happen? It has to take it the diversion. So at that time, so the body, the parts of the body, as well as the wheel, steering mechanism, everything would cooperate in order to ensure the stability of the robot. So RTK, real-time kinematics. Once we started for teaching about the real-time kinematics for the robot designs, that will really useful for the students community. And yes, in case of the computation control, NVIDIA, Justin and Intel Atom, NVIDIA is a pioneer for this field. So RTOS, robot operating system, and in case of the RTOS means real-time operating system. Now, so wherever you go for the generic AI as well as implementation of the generic AI into the equipment, what will happen? The real-time data collection, and what about the time taken to send the real-time data, collected data from the real environment to the operative environment or analysis environment? So that plays a major role. And locomotive and manipulations, these are the quite common. Normally the speed is limited to up to 2 meters per second. Honestly telling, the 2 meters per second is very high, especially at the time of doing the analysis part. So for the warehouse applications, up to 1500 kg. But so just 10 to 15 years back, the payload capacity very close to 5 to 7 kg. In and around of Coimbatore, especially very close proximity of Saravanampatti, so many number of robot making companies are available. So convey the message and check with the available net sources. What about the companies are available or locating in and around of Saranamati? Then you might be getting the so many number of data and try to pass the informations to your fellow students community. You try to provide the opportunity for to learn such kind of the advanced, not advanced, to day-to-day life technologies by the way of getting the internship from the industry is concerned. That would definitely the turning point of our fellow students community. But in case of somebody might be having a very good awareness about the ISO or safety compliances, in case of the industrial robots, ISO 10218, wherever we share about the ISO ideas means we know only the ISO or 14,000 series, 9,000 series and TS series. But beyond that, in case of the industrial robot, 10.218 series are available. ISO TS 15066 applicable for cobots, collaborative robots, not cobots, cobots, collaborative robots. So cobots is presently available at Coimbatore International Airport for guiding the passengers how to get the ticket or how to get the passing, I mean the boarding pass, and what about the luggage counter, what are the do's and don'ts, everything. The robo itself directly interacted with the passengers community. That is a superior action of the human invention. Yes, Boston Dynamics. You just try to note down the term Boston, BOSTON, Boston Dynamics. So the pioneer for producing the legged type robots. So such kind of the legged robot design is one of the highly complicated one. Reason is the stability of the robot is purely depends upon the grip, and second thing, what about the angle of inclination of the joint, right? So once the coordination is not up to that level of the balancing, so definitely the mission will get easily failed. But Boston Dynamics is now the pioneer for producing such kind of the legged robots. So such kind of the robots and wheels are available in case of the Chandrayaan project, right? The lander. So lander is a rover. That rover is also having some kind of legged wheels. I mean the legged robots as well as the wheels. So Roomba, in case of the Tamil, room boy, right? Wherever you visit the hotel, we call the room boy for making the service. The terminology is coined as a Roomba. So Roomba is a cleaning type of robot available in wherever you go for the malls. What about the cost? Very close to 25 to 30,000 rupees, right? Is it need to charge? No. It has to charge itself. If the charge is gets down from the defined level, immediately go and charge by the device itself. Would be evacuate the collected dust from the basket? No, you just tailor made. Once you pre-programmed where actually the collected dust to be disposed, everything it has to be done by the device itself. And second thing, so absolutely, there is no need for level-based maintenance for such kind of the Roomba, right? But limited life, wherever we use the sensors, so sensors are highly sensitive with the environment, right? Suppose at the time of your inside the hall, so you have to pre-program everything programmed through your mobile, right? Android mobile. So whenever, suppose if you are out of your home, then the instructions may be given to the device for making the cleaning and other activities. Such kind of sophistications have been enjoying with the people of Tamil Nadu also, right? So no need to go for European nation or United States of America, such kind of the developed nations. The India as well as the Tamil Nadu itself, we are enjoying with the level-based technological evolutions. And in case of the BMW as well as the LG Electronics, already implemented industry manufacturing. And very common word now, usually in case of the industry peoples often be utilizing the word is namely one is the horizontal integration and another one is the vertical integration. In case of the horizontal integration is the digital manufacturing. So from the design to from the design to value chain, everything to be digitized, right? That is called as a digital manufacturing. So here this is a horizontal expansion. So in the part of focusing mainly on the horizontal integration. So what about the end-to-end digitization, digital twins, simulation technology, and simulation before production, because in order to avoid the rejection, simulation before production, integration with IT. Here the IT is the information technology and OT is the operational technology, right? Integration with information technology, operation technology, IT is related to cyber physical system and OT related to the execution part, and data driven decision making. So collection devices collect the real environment data, then directly send it to the decision making system, everything covered under the horizontal expansion. These are the essential elements of digital manufacturing, right? So so I hope that yes, best example for in case of the digital manufacturing, once you look at the welding is actually happening over this place, but in case of the after successful completion of the welding only, we know that by the way of traditional or non-traditional techniques, apply over the welded portion or extension of the welded portion, then ensure the quality, right? So the quality is being ensured after completion of the work done of the welding. But now such kind of the device helping us to know about what about the temperature, what about the deposition rate. So everything to be controlled, this parameter, welding parameter is directly being controlled by this device. Then you can directly verify whether the process is going on as per design. So these kind of the things are commonly implemented over all kind of manufacturing industries as of now. The outcomes of this kind of the effect is, number one, cost reduction, number two, high end quality, number three, very good life expectancy, number four, so defect free productions. So in olden days, if you suppose in case of the bulky items, out of the 100 might be 5 to 6 items, whether knowingly or unknowingly, coming under the accepted quality ranges, because you might be knowing very well the 5% is right, 95 3 sigma level, but now 6 sigma, you know very well that third 3.2, right, 3.2 per million opportunities, per million products, you are allowing to permit the defective item approximately. This is not the exact value, so keep on changing. So as of now 3.2 out of 10 lakhs, 1 million means 10 lakh. In case of the 10 million opportunities or 10 million product, 10 lakhs products, then you are so permitted to make it a mistake for only the 3.2 chance or 3.2 product. That is a power of the Six Sigma concept over the manufacturing scenario. In case of the digital, yes, the physical asset, physical environment, here the simulated environment, digital twin. So what about the real life scenario, real life operation, everything directly connected with the simulation technique, the real data being directly transferred to the simulation tool, then it simulates the real life situation. So no need to make it a prototype for producing the goods or producing the components with defective free or cost effective. Such kind of the things could be decided by with the help of the digital twin technology. So here the digital twin is also a hot cake, especially for automotive sectors, right? So as you know very well, Chennai is the hub of automotive components manufacturing unit. So if our students well equipped about the digital twin technology, absolutely there is no employment. So there is no employment word is completely replaced by every one of our student got placed in the job market. Such kind of the words comes to true if our students would be aligned with the demand arised by the industries, the demand submitted by the industries. The industry demands that yes, our student would have a basic exposure related to the digital twin, but our students know very well about the simulation with the help of ANSYS, with the help of CFD. But in case of the digital twin is differed from the so-called ANSYS simulation or something else, but these are the created environment, but digital twin is a real environment. That is a basic difference between those simulation as of now utilized. And yes, in case of the vertical integration, the smart manufacturing. So the difference between the digital and smart manufacturing, digital is a horizontal expansion, horizontal manufacturing. Smart manufacturing is a vertical manufacturing by the way of incorporating the CPS, cyber physical system. So Internet of Things, industrial Internet of Things, IIoT, then AI, I mean artificial intelligence, and real-time data analytics. So that is a big data analytics to create the intelligent self-optimizing factories. So what about the basic knowledge actually we need to know about? So there are totally 5 layers are available for the smart manufacturing industries. One is the physical layer. So from the collect the real-time environment of the machines, the robots, CNC, computer numerical controlled machines, the position of the conveyor, sensors and actuators, everything connected directly with the physical layer. So that is the transfer of the information from these devices into the decision making body. But control layer, program logic controllers, right? Program automatic controller, PACs, SCADA, supervisory control and data acquisition. Operation layers, MES. These are the new terminologies, not the new for the industrialists. But in case of the teaching community, we need to equip ourselves about the MES, manufacturing execution system. All kind of the large scale industries, so they have already utilizing the MES concept, manufacturing execution system. Wherever you have a automation system, automation adapted for industries, then definitely this kind of the layers are playing a major role. But the thing is, we need to know about manufacturing execution system, MES, monitors production, schedules jobs and tracks resources. The device actually here the best example of the MES. So here the operation is going on with the help of so many number of sensors are available. The sensors directly sense the heat, then sense the layer deposition, sense the solidification rate. So everything directly collected from the environment, then passing into the decision making system. The decision making system, there are 2 kinds. One is manual intervention and second one is a auto decision making system. We initially made it a tailor made that yes, I need to have a build quality of these things. These are the setting parameters. The environment not supposed to disturb to obtaining the quality of the weld. So the decision making system itself make it what about the adjustment to be made for ensuring the quality of the weld. So this is a best example for manufacturing execution system. This is a part and parcel of the smart manufacturing. And second one is the enterprise layer, ERP, enterprises resources planning, customer relationship manager and supply chains, cloud analysis. As you know very well about the cloud computing, cloud analytic layers. So here ERP, there are 3, but so whether knowingly or unknowingly, we might be having a very good idea about the SAP, right? SAP Business One is a very good ERP software, and almost all kind of the factories might be. But in case of other than the SAP, so many number of modules are available in case of the SAP. Once our students got the, supposed to get a minimum level certificates, grade 1 and grade 2, then Bangalore, Pune, so many number of vacancies are available. You try to inculcate such kind of the good message, what you received from my end. Yes, I keep on addressing to my students. You try to learn beyond the working years. Such kind of the things may not be available in case of the curriculum, right? So the SAP, once you learn about the SAP, in almost all kind of industries already implemented the SAP, that is a enterprises resources planning, or other than the tough competitor for SAP is ERP, Oracle and Microsoft Dynamics 365. So in case of in India, especially for Tamil Nadu, SAP is playing a key role for. What about the advantage of this ERP, real-time monitoring, autonomous decision making, integration of information technology and operation technology, adaptive productions. So these are the quite common for. Yes, in case of the smart manufacturing, one case study actually, Cipla is one of the very good, very famous pharmaceutical company, headquarters located at Mumbai, right? with the help of here the active pharmaceuticals ingredients used in many medicines, APIs. So one of the, in case of the pharmaceutical industries, the mixing of ingredient ratios is one of the critical tasks. If the task varied, that is the reason behind, once you get the tablets, you try to look at the tablets expiry date, same tablet, but same pocket. So cluster of pockets might, but the date might be different. Some kind of the tablets pocket mentioning that 1 year duration, some of the pockets might be 6 or 1 year or 2 years. The duration of expiry is purely depends upon the mixing ratio, right? But here the Cipla manufacturing, pharmaceutical manufacturing company implemented the direct control distribution control system. DCS means distribution control system. Thematic PCS. What about the, yes, here the 1935 headquartered in Mumbai. So provides over 1,500 products across various therapeutic areas with various strong focus on respiratory health. But what about the most advantage of these things? Here, number one, perfect mixing ratio. Number two, expiry date, extended expiry date is depends upon, number one, the storage time, right? Storage time of the raw materials. Definitely, it is not supposed to be utilized for tonnage of tons of raw materials would be processed as a tablet for a single time frame, right? If the storage time extended, what will happen? That would directly reflect over the expiry date. But here, if you are producing the exact composition of the mixing ratio, then that would directly reflected over the printing of expiry date of the tablet. And the second thing is a quality. So both would be enhanced. This is a concrete evidence of Cipla. Once you check with the case study of the Cipla with the help of semantic, right? Semantic PCS 7 distributed control system means you might be getting a lot of information about these things. And another one is a cyber physical system, none other than the cyber physical system, real data collection agents or collection products. So with the help of AI, IoT, cloud computing or digital twins. Here also, so totally very important thing as a 4 layers, physical layer, cyber layer, communication layer, protocol. So here industrial IoT, 5G and OPC. Here the OPC is a open platform communication, open platform communication, unified architecture. So communication layer, OPC UA and Profinet, Profibus, edge computing as well as cloud computing. These are the various things behind the CPS, cyber physical system, right? So what about the role of cyber physical system in industry 4.0? One of the very important thing is links digital manufacturing, horizontal with vertical. That is the smart manufacturing. One is the digital manufacturing related to the design part. So smart manufacturing related to the execution part. The design and execution part would directly, strongly bonded by the help of CPS. The quality of CPS reflects the quality of industry 4.0. That is the reason behind I strongly emphasized about, is it possible to implement over the micro level because of the capital investment behind the installation of the CPS. You know very well about the CCTV, right? So in case of the charged coupled device, the distance, range, so the coverage is playing, right? So suppose in case of the all higher educational institutions, as per latest order issued by the government of Tamil Nadu, so equipped with the CCTV, right? But in case of the CCTV, the government never emphasized about the range of coverage. But in case of the range of coverage as well as the quality of picture taken by the device, that would directly reflect at the time of decision making. So that is also energy optimization, right? And the third one is the human machine collaboration, HM, collaborative robots on AR and VR. So augmented reality as well as virtual reality. So let us see about the augmented and virtual realities. So for the forthcoming slides, before that, IoT and as well as IIoT. So a network, establish the network among the physical devices embedded. As of now, the new revised syllabus by Anna University. So one paper is a common paper for all domain. So this is not the domain specific embedded system. This is a common paper for all disciplines. So from the 2025, those who have already joined in the first year, right? They have to study about the subject. I hope that if I'm right, second semester, because of physical devices embedded with sensor. Yes, we saw about the eyes, artificial eye made by the additive manufacturing technology, that is embedded or infused camera, right? Embedded means that is a part and parcel of the body itself at the time of functioning of the body. Yes, the embedded system embedded with sensor is one of the very important thing behind the predictive maintenance of the machines, right? The embedded Internet of Things is the best example for our cars, right? In case of the car, any problems happen over the interior of the engine that shows some blinking images, right? So check with the water level or check with the coolant level, check with the socket level, everything displayed in the device, right? That is an example of IoT, Internet of Things. So smart home devices like thermostats in your refrigerator, right? Suppose how do you set the 3 degrees Celsius? Suppose if beyond the 3 degrees Celsius, what will happen? It make it a bend and connected with the electric circuit connections. Thermostats, wearables. So in case of the wearables means our body itself started for producing the power while walking, right? Your shoe started for making the electricity, right? So connected cars, V2V or V2X, vehicle to vehicle connection or vehicle to everything communications. So these are the example for Internet of Things. And in case of implied over the industrial environment, industrial Internet of Things, but the selection of sensors, selection of the physical, cyber physical systems, everything is depends upon the applications. So there is no commonality for the selection criteria for the CPS for IIoT. Depends upon the applications. Yes. Tata Nexon, right? Electrical vehicle, best example for IoT enabled. And second thing, ADAS level 2. So in case of the ADAS, so driver assistance systems, right? Suppose if you are very close to, if you are want to change the lane, so immediately the device, incorporated device says that, so this is the right time to deviate, right time to not deviate of the steering location. And the second thing, vehicle to vehicle communication, everything available in case of Nexon car. You try to discuss a fruitful discussion with the dealers of Tata Nexons, you might be amazing. So many number of sensors application. Almost all kind of the nowadays have been utilizing the cars equipped with sensors. That is called as a electronics control management, ECM. Electronics control management. So many number of sensors are already equipped for continuous monitoring and continuous execution. So the signal command given by the control unit that should be executed by the sensors by the way of, say for an example, LVDT, right? Linear variable differential transducer, right? In case of the DVT, LVDT, suppose if you want to execute, then signal directly sends to the LVDT and LVDT so starts for its assigned function. And here also so many number of layers are available. Suppose if anybody interested about the IIoT, you try to check with the IIoT enabled industries. Instead of listening such kind of the terminologies, once you physically look at the fixation of physical cyber system, I mean the cyber physical system, obviously the CPS, then you might be knowing about the different kinds of. Yes, at the time of COVID, right? Thermal scanner. So the thermal scanner is being directly utilizing the infrared rays, right? Your body temperature is directly analyzed by the thermal scanners, right? Scanning the image by the way of knowing the temperature. The temperature is directly converted into the signal, then the signal converted into the display, right? Such kind of the mechanism behind. So these are the quite common for the real time usage of. So digital thermal vernier is also the part and parcel of. Definitely it has some strain gauges or it has some verniers. It has some sensors. So nowadays, normally the strain gauges are the lower end and LVDT is a lower end than that of the sensors. Reason is sensitivity. So sensitized to understand about the real situation, real environment. So that is the reason behind. Now, what about the cost of the sensor? Depends upon the spec, depends upon the individual specification, but at lower end. So for making the prototype robo, very close to less than 25 rupees, right? Suppose in case if you want to buy it some kind of the vision sensors, but lower range. So especially triple TDM, right? Triple TDM located at Kanjipuram, not exactly Kanjipuram, the way in between the Vandalur and Kelambakam. Every year they usually conduct robo laboratory training program for school kids as well as engineering college students. You try to visit over the triple TDM. So then you try to inculcate the students community to periodically visit the triple TDM website. Once you apply it, so very good training you might be receiving. Another very important area of the IoT is the augmented reality versus virtual reality. Augmented reality means physical environment. There is no virtual environment. So you have to adapt the technique over the real world environment. That is not the imaginary or that is not the virtual. So here that is a smart glass, right? The smart glass itself, once you wear the glass, you can identify so where actually you want to execute. So such kind of, yeah, in case of the physical environment, everything is displaying over the screen, but that is not physically exist. So the virtual screen, so to give the instruction how to you execute, right? But in case of the physical environment, suppose once you wear the device and everything pre-programmed, suppose I don't know exactly how to operate the milling machines, right? In case of you made it a tailor-made program how to operate the real milling machine, then everything pre-programmed. Once you wear it, so the smart glass screen, so the generated screen says you that you check the safety precaution first and where is the power button. So do's and don'ts and what are the step-by-step operations to be carried out over the particular machines. Versus virtual, you don't need any milling machine. So how do you operate the milling machine? Everything virtually developed. Then once you wear the apparatus, then no need for any physical devices to learn the training. That is a superior advantage of VR. Then almost most of the training division no need to do for the any physical training offered by the newly recruited employees, right? They go directly for the virtual laboratory, virtual reality, I mean virtual manufacturing, virtual reality laboratories. Then they could get the real time, not exactly real time. What are the activities to be done in case of the real time environment? Yes, this is the scenario. This is a real scenario actually experienced by the MNCs, not only MNCs, indigenously developed factories too. Anyway, so due to a restriction of the time, so I will just go for a rush. Well, so these kind of the things are readily available in the available resources, right? In case of the virtual reality, one of the best thing is, so here no need to procure any physical items, no need to spend even as a single penny, right? In terms of in Indian money, so no need to spend even as a rupee for procuring the items for making the perfect training. So Akalas, HT5 and Varjo, these classes are commercially available in case of the Amazon platform too, right? Akalas cost, the what about the price range is 55,690 after the deduction, 10% deduction, right? You check it with. So yes, in the Government College of Technology, so we have the AR/VR setup. So thanks to Government of Tamil Nadu, so offering the 50 plus 50 1 crore rupee for establishing the AR/VR laboratory setup. ECE department, actually I am the in charge for procurement of these items in association with the DOT. Then transfer these items to the electronics and communication engineering department. So once you go with the GCT ECE website, then you might be receiving some kind of the positive information related to AR and VR. Another one is HTC Android by 97,990, like I said, beta shoe rupees, right? So 98,000. And here just imagine Virgio VR3 HR sets 5 lakhs 30,000 rupees. But what about the reason behind? The quality. And second thing, yes, do we have any freedom to develop? Do we have any freedom to develop our own module? Yes, in case of the cost component to be hiked, what will happen? Flexibility. Once you look at the initial device, tailor-made. So whatever the program we need, everything tailor-made. We don't have any possibility, we don't have any flexibility to alter. But in case of the keep on raising the initial investment, then what will happen? It allows us to change. We need to incorporate whatever the modification we want to do it. So these are the things actually. Yes. But the Sony, thanks to Sony, now less than the Oculus and Vive devices, it does mean for, yes, less than 50,000 rupees. Yes, we need to procure almost all English movies. Yes, Oscar winning movies, The Lord of Rings, right? The Lord of Rings first initially introduced about the concept of, especially for the digital revolution. So AR and VR concept, right? But anyway, so AR VR is help us to, what about the utilization, safety training, maintenance, and in case of the collaborative engineering, so teams across the geographies meet in VR to co-design and optimize product. The VR is really helped us, especially helped to the ISRO for simulate the environment of land. We successfully landed our rover at the most southern part of the moon, right? Lot of simulations, lot of AR and VR studies. So happen more than yes, yeah, more than a couple of years. Then only we got a very good success. The mission was a success because of the thanks to AR and VR technologies. Big data analytics, so related to computer science and engineering, right? So what about the big data analytics? Just a best example here. According to the Forbes, this is a last year value, 2.5 quintillion bytes of data is generated every day. Just imagine, 2.5. You just look at the, measure the number of zeros, 3, 6, 9, 12, 15, 18. Yes, 1 multiply by 10 power 18. Just imagine data every day. This the data related to last year data, right? But this year might be doubling or tripling. What about the basic applications? Predictive maintenance and process optimizations. What about the, in case of the cloud computing? Yes, no need to procure any kind of the workstations, right? All, yes, Bharat 6 is one of the basic limitation for procuring a component, I mean the producing the component by the automotive industries. So best example, you never find any kind of 1.3 liter petrol or diesel, right? 1.3. So now because of the introduction of turbocharger as well as because of the restriction behind the BS6 norms for NO NOx components, in case of the especially for diesel engine shifted from the 1.3 liter engine into the 1.5. But petrol engine shifted from the 1.3 liter into the very close to 1 or 0.9. So you look at the automobile markets, 3-cylinder engine, reason is limitation. But in case of the China, all, I mean the mobility vehicles are directed with the cloud. If the norms exceeds, what will happen? Immediate fine. So thanks to government of India, still yet to implement such kind of the cloudly connected with our vehicles. If the vehicle is directly connected with clouds, what will happen? We are directly, our mindset is shifting towards from the individual into the common transport domain. In case of the common transport, a bus, just imagine 52 passengers, but 52 passengers in a single, but in case of 52 individuals drives their car in a common platform. just the space requirement. Second thing is a fuel usage. Third one is a eco, environment conditions. And fourth one is a directly reflect over the GDP, right? 85% of gasoline or oil products directly imported from. That is the basic reason behind the tax war, right? You know very well. So we have been taxed for more than 50%. But the reason is, yeah, the lot percentage of the oil is directly procured from Russia. But once prevent to utilize the individual for making the very long journey. Once the government is started for introducing, yes, so monorails in case of the Mumbai, right? So after induction of the metro rail at Delhi as well as Chennai, what about the distance between the Punamalli and or in case of the central to airport, if you are driving by car, very close to 1 hour 30 minutes, right? But in case of metro, very close to 47 to 48 minutes. Just imagine the time saving, cost effective, fuel saving, and directly contribute for the well-being societies. So these are the things behind the important. Yes, in now the infrastructure as a service, engineering college as a service for, no need to make it a separate complex are required for teach the students. Infrastructure as a service, latest things, platform as a service, software as a service, teacher as a service, tuition, online tuition, right? So many number of things are available in case of the, yes. What about the impact over GDP, jobs, society, especially on Coimbatore textile and pump industries are directly now utilizing the smart concept in order to ensure the quality of the things, quality of the end products. In case of the CNC machining, more than 5 axis. Degrees of freedom is one of the important criteria, especially at the time of teaching the kinematics of machinery subjects to our students, right? DOF, design of freedom, right? So in case of the degrees of freedom, not design, degrees of freedom, more than 5 is really too tough. But now, yes, we have been enjoying about the 12 axis CNC machining, vertical machining center with 12 degrees of freedom. Yes, best example is a turbine blade. So usually the turbine blade, so it needs more than 7 axis machining, simultaneous machining actually required to make it a profile. Then only, so lift and drag would be balanced. So thanks to the advanced technology like, yes, medical robots, KG hospital, Ganga hospital, they are now deploying the robots for making the surgery. But one of the critical surgery, especially for the human being era, that is ARNA, is only the brain surgery. So in case of the brain surgery, normally the time frame is very close to 10 to 11 hours. If any misplaced, then the recovery rate in terms of months, that would perfectly done by robots directly deploying for making the operation. No need of so many number of sisters assisting to the doctor. Yeah, so many number of robo hands, robo structures directly helping to the doctors for do the operation based on the commands given by the doctor. DNA, redefined DNA, right? Redefined DNA, regenerate DNA, redefined codes of DNA. Yes, now most of the healthcare industries now showing their keen interest. So what about the outcomes? Absolutely. What about the age? 200, 300 years. What about the aging? Starts as only that 120 years, then only being treated as a youngster. So might be knowing about the during the King Rajaraja Chola period. Once the moment started for the 70 years, then only the young child. Then 120 and above, yes, aged. Such kind of the redefined life might be expected by the healthcare industries as well as like us. So because of the DNA recoding done by these kind of the technologies, right? What about the future trend? Yes, future is purely depends upon the communication portal. So in what way you have to communicate with the guys? So 5G or 6G or 7G, edge and cloud computing, AI driven mechanism, and near future development, knowing very well about the blockchain, right? So blockchain, in order to avoid such kind of the threats as well as the misusage of the technology, hyper personalization 5.0. Yes, the 3D printing technology. Your shirt size is 40 or 40.5. You can have the size 40.5. Personalization 5.0. Basic thought behind the technique is a personalization. Your chapel size is 6.7. Yes, the market is ready to supply the 6 point. What about the color you want? Spontaneously you decide the color by yourself, like paint. In olden days we have only the limited colors. Now 256 million colors are available. Whatever the codes, you just put it, the mixing grinder itself mixing perfectly. Whatever the color you want to paint your livelihood areas, you can do it. These are the possibilities we are expecting. Beyond the 5.0, what about the restriction? Quantum computing. So bits, right? 1 or 0. But the quantum says that 1, not neither 1 nor 0. Here, either 1 or 0. So there are totally 3 domains. 1, 1 or 0, or 1 and 0, then 0. That is the thought behind the quantum computing, bio-integration, fully autonomous factories, space manufacturing, and conscious AI and human creativities, right? Yes, thanks to the Kerala Engineering College students for pass out from the 2016. The robo name is the Bandicoot. So you try to type the Bandicoot robo, then that is a yes scavenging robo, especially for in case of the manhole. Then the cleaning activities directly being done with the help of this our students also, but they need some fundamental guidance. They are expecting a very good guidance from our end. So once we go to equip ourselves with the on board the latest technology, then definitely Bandicoot, the name of the robo is. Yes, these are the recent trend. Robotic elephant donated to the Lord Shiva temple. Here the message, last February, and here the removal of garbages from the lake, ponds, and so on. Yes, the wild growth of the water hyacinth. So Agaya Tamarai in Tamil, right? The multiple attitude of the development of this hyacinth, what will happen? That would directly so threats to the underwater animals, right? In case of the lack of oxygen supply, so lack of lights passing to the water bodies and so on. Suppose if you deploy such kind of the cleaning robo over the water bodies, then definitely the underwater livings or water livings creatures directly register their thanks to the engineering communities, right? In future, yes, your fiance also might be directly chosen by AI. So within this word, I'm sorry. So I took up to 7:32 because of the interest behind the title assigned. What about the conclusion of these things? Our roles and responsibility, especially for the teaching domain as well as the industrial domain, that we need to inculcate the expected industrial demands directly transfer to the students community by the way of providing the extensive training or at least guidance to where they have to get the proper training. Then what about the outcomes of this presentation? They could directly create entrepreneur, they could directly create the employment market, they could directly create the employers, right? Employers. And what about the fourth? We could directly contribute our GDP by the way of producing the potential professional from the engineering institutions, because in India, so we are the largest, because when I was working at DOT, 465 engineering colleges, almost all now the scenario is good, slowly changed. Most of the colleges, so mechanical engineering strength is very close to 30, but in case of the AI and ML, AI and DS, computer science and engineering with specialization of cyber security, so specialization with big data analytics, specialization with cyber security, I mean the Internet of Things. So many number of specific specializations are being offered for under the domain of computer science and engineering, right? So being a mechanical engineering, it's our responsibility to inculcate our students community the pure mechanical engineering knowledge alone not possible to fulfill the student's dream. They have to have some idea about the integration of AI, integration of electronics principle, integration of generic AI with the mechanical, then absolutely they are started for flying. So the sky is not the limit for our future pillars dreams. Within this word, I register my sincere thanks to all my fellow colleagues and the proactive team members of this FDP. Thank you so much. The forum is open for queries.
Thank you, sir. That was a great session. Very informative.
Thank
Participants, if any queries, please post them in the chat box.
Thank you, sir.
Chat box totally 5.
Participants, you can ask your
Very good
questions in the chat
informative.
box.
Yeah, feedback from link. Thank you. Dear, apart from thank you, right? Because very close to 70 minutes, right? 70 to 75 minutes. So we have spent our valuable time because both of us family guys, right? So we sacrificed our personal lavishness by the way of getting the exposure. Definitely a single session, I never claimed that all 70 minutes information directly transferred to the fellow guys, right? But the thing is, everything, so because thanks to the AI, generic AI, you try to learn very easy, but because in case of once upon a time, the coding, so the coding skill is one of the important criteria for getting the employment, especially for the software industries. Now, if you are having the coding skill, so what? Why should I observe in my company? Because ChatGPT is, once you type it, whatever the codes, just a matter of a minutes with the testing performance, right? So software testing is one of the critical domain for software industries. The test results also published within the time frame. No need to wait for the days together. Minutes together would result that whether feasible or not. So now we are living that era. Any possibilities in reframing the curriculum and syllabus in integrating mechanical and AI? Yes, sir. So I am the member for Anna University, right? Board of Studies member for non-autonomous institutions. We provided so many number of inputs. So for more than a year, right? A team consisting of very close to 25 plus senior professors. So that is the outcomes of the integration is we introduced the embedded system for all irrespective of the engineering specializations. So in future, definitely because once the students might be knowing about how do we integrate between the CPS, cyber physical system, with the execution system based on only the embedded technology, embedded systems, right? But exclusively embedded is related to the electronic communication era domain. But being a mechanical, it's our responsibility to know about the fundamental. So many number of NPTEL courses are available. Don't rely only on the syllabus. Point by point, word by word, from the printed content, not supposed to helping the students community to develop their skills domains, right? My suggestion to my fellow faculty members that you try to visit the NPTEL website, right? NPTEL website, so many number of programs are offering by various IITs. So I was trained at IIT Hyderabad. Hyderabad facilities are really very good. So at the time of attending the program, one of the professor came from Israel, right? So came from Israel and they explained so many number of, yes, the quantum tunneling effect was discussed in the year of 2016, 2016, right? So that time, so he spoke about the impact of quantum tunneling effect. The thing is now only, so the supercomputing techniques as well as the quantum computing techniques are slowly emerging, especially IIT Mumbai, IIT Kharagpur, Kanpur, and Jadavpur universities. They are having the very good faculty members so to teach the quantum computing. In future, definitely generic AI, definitely quantum computing technologies. So these two things are playing a very well role. So it's our role to know about something related to quantum computing, and second one is quantum computing, and another one is integration of these things. Sir, please tell, is there any software available to detect the disadvantage of AI ML for specific applications? So yes, any software means the software itself work based on the AI and ML, right? ML is a large scale, right? Suppose if the speech to text, right? Large language model, LLM. So without AI and ML, as of now, absolutely there is no software could be utilizing for identifications. But anyway, so many number of disadvantages are be there. So usually they generally termed that, yes, employment market for the human being. Yeah, before this presentation, I shared my views with the organizers, right? Now the team made of a robot dog, then the robot dog is placed among the group of dogs, then what will happen? So started for fightings, right? Started without no identifying the dog was made by the no, so started for fighting. The same scenario might be expected, unless otherwise we have the upper hand to control over the humanoid robots. So whatever the things, still there is no replacement of our brain, right? There is no invention for alternate for our brain. So thanks to God, and suppose if not faith over the God, the nature. So thanks to the nature for still there is no alternate for number one IC engine, number two induction motor, number three our brain. Among these three, number one is the brain, number two is the internal combustion engine, and number three is the things. Sir, will the quantum tunneling effect will have a large impact on mechanical engineering? Should mechanical learn quantum computing in future? Is it very important? Absolutely, because so as usual, you might be knowing about the group machining, right? So we studied about the gang milling, gang drilling, right? Multiple number of operations to be done at a single time slot, right? Say best example is a carburetor. Now the carburetor is totally absolute, but in case of the olden days, carburetor, there are the two holes. One is at exactly with respect to the vertical 45 degree or horizontal with 45 degree. 45 degree hole as well as the vertical hole to be done at a same time frame. If not, what will happen? Assembly will not be. So that time, multiple number of operations to be done at a single time. Up to 7 or 8, yeah, we can do it. But beyond that, then definitely the chances for making the errors. In order to avoid such kind of the errors, definitely we have to rely only on the computing skills. The computation skills means we need to develop the codes. That time, definitely we need to know about the quantum computing. In the future, definitely the quantum computing might be playing a crucial role for making the decisions. Sir, any questions beyond that? Dears? Hello? Hello?
Participants, if any other questions, please post.
I hope that time is 7:43. Okay. If there is no questions from the participant sides, yes, I have so many number of presentations. Links are available in my web page, personal web page. You directly go for Shekhar, GCT Mechanical. So now taking the role of the PG manufacturing head. So many number of sensor based technologies, industry, materials, advanced materials. So latest trend in the materials engineering. So many number of presentations, the links are available. So no need to get any permission from anyone. You could directly go for visiting my websites. You might be getting very good exposure from the latest update. Within this word, thank you so much for providing the very good opportunities to meet the young and energetic fellow guys. And thanks to the organizers.
Thank you, sir. Now I request Pratap sir to give a word of thanks.
Thank you, sir. On behalf of the organizers, our heartfelt thanks to Dr. Shekhar, Head of Department PG Manufacturing, Department of Mechanical Engineering, Government College of Technology, Coimbatore, for delivering an insightful session on present and future trends of Industry 4.0 in the AICT Atal-sponsored Faculty Development Program on Advanced Manufacturing and Industry 4.0. Your expertise and keen insights have enriched our understanding of Industry 4.0 present and future landscapes. We appreciate your time and effort in sharing your knowledge with us. Thank you for being part of this program and contributing to its success. Thank you, sir.
Thank you so much. Thank you. Shall I leave?
Yes, sir.
Yes, sir.
Thank you.
Yes, sir. Thank you. Participants, the next session is about to start.
Hi, sir. Sridhar here. Sir, let me know when can we start the session?
Sir, within 5 minutes, sir.
Sure, definitely. And also just help me out to just enable my video permission as well.
Yeah, sure, sir. Yeah, sure, sir.
Yeah, thank you. Sir, I hope my screen is visible for everyone, right, sir?
Yes, sir.
Yes,
Yes, sir.
please.
Perfect. Thank you.
Rajesh, you can start MC. Rajesh, sir. A warm welcome to Mr. S. Sridhar, Managing Director, Intrino Robotics and Technologies, for day 4 session 2 of the AICT Atal sponsored online faculty development program on advanced manufacturing and Industry 4.0. We honored to have you discuss Industry 4.0 and smart manufacturing. Your expertise will provide valuable insights into the latest development and future directions of Industry 4.0. Thank you for sharing your knowledge with us. We look forward for your informative sessions. Now I request Dr. Manoj Prabhakaran to give an introduction about our speaker. Thank you.
Good evening, everyone. We are delighted to welcome Mr. S. Sridhar, Managing Director, Operations at Intrino Robotics and Technologies Private Limited. With over 9 years of experience in both academia and industry, he has trained more than 8,000 students, faculty, researchers in robotics and automation. An alumnus of Madras Institute of Technology, Chennai, he holds a BE in Mechanical and ME in Mechatronics and is currently pursuing a PhD in robotics. He also earned an advanced certification in Industry 4.0 from IIT Delhi, bridging cutting-edge industrial practices with academic learning. His expertise lies in robotic system design, sensor integration, control, and smart manufacturing, with a strong focus on hands-on practical learning and industry-ready skills. We are honored to have you, Mr. Sridhar, with us today to share his knowledge and insights.
So now the floor is yours.
Yeah, so thank you, everyone. I believe my screen is visible to everyone and my audio is clear, right? Is my audio
sir.
clear?
Yes, sir.
Yes,
Yes,
sir.
sir. Your audio is clear.
Yeah. So fine. So thanks for the introduction and thanks for CSI Engineering College for having me here just to just share my experience mainly on Industry 4.0 and the smart manufacturing. So just a small brief of what exactly my profile is. Yes, I completed my bachelor's in mechanical engineering and I did my master's in mechatronics in MIT, Madras Institute of Technology, Chennai. Currently, I'm also pursuing my PhD in robotics. So this is my just educational background. So when it comes for industry, almost I do have 6+ of years of experience when it comes for mainly working on innovative system implementation. Mainly on this Industry 4.0 integration technologies. And during my course of profession, I was also had an opportunity to learn on exact Industry 4.0 integration technology, which is an advanced master course program from IIT Delhi. So which opened my floor to learn things with everything which is completely into practical. So that was my eye opener session when I was doing that. So with that insights, I would just start my session. So myself, Sridhar Shankar, from founder of Intrino Robotics and Technologies Private Limited. So when starting this firm, we have been very clear that we are going to be concentrating on digital twin as a service model. So digital twin, yes. So that is the very futuristic technology. Now, even a very big companies are working towards that. So we were very clear that the company Intrino Robotics and Technology wants to be an a very good player on setting up the digital twin for the manufacturing companies, pharmaceutical and automotive sectors. So we have tagged in a company that robotics and technology, where we're going to work with manufacturing machine assets and we work with the latest technologies. So that is how the company's vision is all about. So these are some of the snippets where we showcase our developed products to different clients globally. So as in a company, so we have categorized into 3 domains. So one is Intrino Robotics and Technology, which is completely headed by myself. So with the team members of 8, And we also have an other vertical called Intrino TwinX, where this spatial AR, VR, MR technologies have been incorporated along with IIoT communication for the platform. So this is the completely managed in an Intrino TwinX, which I take care of the managerial and basic level of operational roles. So the complete indigenous team is different. And also we do have our own training institute where we do train most of the corporates on emerging technologies. For example, so we train some of the government professionals to incorporate some of the easiest adaptable safety technologies into their floor plans. So luckily, like we do corporate trainings mostly, and some kind of trainings happens in the academic as well. And we also do most of the faculty development programs. So this is our team. So myself, I completed my course in IIT Delhi, and also I'm an alumni of Anna University MIT campus. And we do have our core team who's completely into engineering background. And we also have a team size of 6 members in a different skill set, which will be completely taking care of development of AR, VR products. And the technical team takes care of IoT communication for the same. So this is just an overview about what exactly the Intrino group of companies is doing. As said, we have 3 different verticals to further take you. So these are some of the clients that we work with. So we mainly work with different variety of clients. Maybe this is just a few portfolios that we always showcase to the participants or people. So we work with BMW as a major projects, mainly setting up their complete visualization for their whole factory, which is in the Chennai Mahendra city. And L&T, we work with their offshore simulation platform, which is in the Gujarat. So we have our team who's dedicatedly working for this L&T Mumbai for setting up their offshore simulation platform. And end of the day, it will be converted to be a digital twin platform. So we work with, so these are some of the clients, and we also develop our robots and we supply to the National University of Oman, the Ananda Sagar University for AR, VR solutions. For the government of India, like we support their training programs, and we also support them to incorporate the emerging technologies when it comes for AR, VR, and how the recent advancements in the digital twin technologies and recent advancement in spatial technologies can be integrated into the present government policies. So we have been doing it for the past 3 to 4 years with the government of India, especially to be really clear, RLI Chennai. So, and we also had small project which worked with Sony Music, and Doosan is one of the very good South Korean robot companies. We started our first application development with Doosan, a South Korean robot company. And we also been associated with some of the tier 1 engineering colleges in Chennai. So this is our small portfolio. So now, just coming up with the actual agenda for the session. So I think the professor, Dr. T. Segar, so he was very good in explaining about all the technology implementation, present industry needs, industry 4.0 implementation strategies. So luckily I had an opportunity to attend the last 30 minutes of session. I could able to understand his complete perspective on what exactly the future industries are moving towards. So what makes a small difference into my session is here I'm not gonna be explaining much on the theoretical aspect, but rather I would be sharing most of my industry experience with you all. So why we choose this technology, why we don't choose that technology, and what was the problem when we were implementing this technology, and how do we propose our solution, and which kind of technology will be adapted for the problems that is arriving in the industry. So these are some of the practical exposures. Maybe in typical corporate language, we used to tell as an KT session, knowledge transfer session. So that's how I wanted to explain and share my insights with every participant here. And first of all, thanks for all the participants who have been consistently attending the session from 6:30 till now. And also, like I could see, participants are looking for some kind of knowledge thrust and how they are going to utilize for their academic roles. And so, and also just to add a small insight on that, I was also a former professor. 3 to 4 years I was into teaching. So I was appointed to teach in mechanical engineering. Then I just pivoted to the other department, artificial intelligence, mainly taking care of physical AI integration there. Then out of my business passion, I just quit the job and started my own company. So that's my just a part experience profile as well. So I'm not going to discuss much on the basic conventional term, but as an overview, yes, we'll have to just touch it up, and then I'll be taking up to the next slides accordingly. So yes, at presently, if I ask any of the participants, or because I used to handle many sessions, I ask like at what industry revolution exactly that our Indian market is at presently. So I could see like most of them will be using the words as like we are in industry 4.0. All the industries are running at 4.0, and some will come up with the answer as industry 3.0. But to be really specific, large volume of Indian companies are presently in industry 2.0. So they have their conventional mass production assembly line, which is being completely worked with the human laborers. So majority, I'm not talking about the elite category of industries like Siemens, Bosch, BMW, Hyundai. So I'm not talking about elite. So on a put a whole on an Indian market, so we could see like most of the industries are running in the industry 2.0, but the top elite companies have already successfully implemented on industry 3.0, and they are now literally trying industry 4.0, not as a whole process, but in a small segment of area. So as rightly said by the Dr. T. Segar, implementing industry 4.0 is an hectic capital expenses deployment. So we need to invest huge money, we need to invest huge resources to train implementation, timing strategies, and everything has to be done so that people are now testing out with the small segments. So industry 1.0 is mainly about the just development of systems, which is mechanical or steam engine based power systems. And when it comes for industry 2.0, it was purely based on mass production. So we don't need to care how efficient we are producing, but our ultimate aim was just to produce in the mass. So that is how it was started. And then just to eradicate some of the inefficiencies in that industry 2.0, people started to integrating the proper automation systems and mechatronic systems, computers, electronics. So in the industry 3.0, we don't use the word or AI. We will not be, there are dedicated controllers and electronics which does the wholesome objects, wholesome process in a neat manner. So industry 3.0 is running at most of the elite category of manufacturing companies in Indian market. So this is just an overview, and now we are presently marching towards make the whole industries to be in industry 4.0, and we also parallelly have the other segment as industry 5.0. So what makes a small difference between the industry 4.0 and the industry 3.0 is industry 3.0 is a complete end-to-end automated system where we do have dashboarding system, where we do have HMI devices, and where every control parameters has been done locally, and we don't have any communication that has to be taken to the some other location. So industry 3.0 is about automation systems which is inside the factory premises, no communication with the external world. There is no data transfer happening beyond the industry. When it comes for industry 4.0, we talk about the CPS system, that is nothing but a cyber physical system. Whenever you use a word called cyber, yes, the number one, we are taking out the data towards the cloud platforms. And why do and the first question will be always starting with the some of the industries in India, especially if I talk about Chennai. First they will be questioning us is it that needed we should have our data in cloud? Because that has its own capital expenses. Indians are very clean in conservative mindset. We will not be wasting most of the money. So whenever there is a need and whenever there is a problem which can be solved by industry 4.0, then the companies are ready to invest in that. So now first question will be starting is whether this automation system which I am presently in industry 3.0, does it need to be converted into 4.0? Why should I take my data to the cloud? So that should be some positive use cases when we wanted to push the data to cloud, right? So if I could able to justify to the client in that manner, then it is easy for us to implement the industry 4.0. So every technology should start with the business requirement. It is not as an engineering graduates and engineering professors, we directly start working on the technology. Yes, I was also doing the same when I was into that domain, but now it should have an actual demand that we wanted to implement that technology for this problem, which is going to create this much of profitability or efficiencies to this process. So that is what. So now as an industry 4.0, all the assets, I use a word called asset, The assets is nothing but every individual machine, every individual process components, subsystems, every individual mechanical elements in a factory. We use a defined term called assets, ASSESTS, assets. So these assets have been connected towards the cloud, or this can be connected towards locally. So anything can be done, but the data has to be collected in a common data pooling arena. So when it comes for Industry 4.0, this is the actual technology which was already spoken by the previous professor. Yes, so we have a segmented of the technology. I think the past 3 or 4 days we have been looking into these kind of terminologies. So big data analysis, horizontal and vertical integration, cloud computing, augmented reality, industrial internet of things, additive manufacturing, autonomous robots, simulation of digital twins, and cybersecurity. But here, yes, these are the pillars of Industry 4.0. But my role is for this session, I would be so confined to take three technologies which is most relevant for me to explain about how this Industry 4.0, how this smart manufacturing, how the intelligent manufacturing works. So I would be taking augmented reality solution, and I would be taking this industry internet of things. Then I would be taking about the digital twin integration. So these three major things that we will be discussing in an implementation level. So that is what the agenda is. So first of all, before getting into that, first we'll just start with what is called smart manufacturing. So I would really wanted to give the explanation in a manner that first, manufacturing, yes, we are producing some components by using present or the old conventional manufacturing technologies, and we are producing a component. Now my question is, why should I convert that to be a smart? There should be some beneficiary role which has to be playing in that. So only then for example, to put it in the real-time scenario, we have a lathe machine. Lathe machine is most of the lathe machines in especially in Chennai or Ambattur industrial estate or anywhere, like, so they do have the lathe machine which is completely conventional type lathe machines. So they don't have a smart lathe machines. So why they don't need us? They will not be understanding what are the benefits if that lathe machine has been converted into a smart lathe machine. So here, first question is, the people who is already working with 25 years of experience, 35 years of experience will never look for smart lathe machine because they have a higher skill set. Just imagine if 2 years or 3 years of experience person wants to work with that lathe machine, a technology should be incorporated into the lathe machine telling that, hurry, you are increasing the feed rate, then the tool wear is going to be very higher, then your tool life is going to be. So you are equating with the experience of the 25-30 years of person, and you're bringing with the technology. So here I don't demand for higher experienced person to use my device. Even a 2 years of experience can use my device. So that's the first use cases. What is the benefit of smart manufacturing, converting any machine to be a smart? The first is it removes the skill set, and number two, it gives us a better efficiency, decision making authority. It can also give us the most reduced cost. How does a reduced cost comes under this? If I have a informative like this tool will get weird in another 2 days or 3 days, if there is any data which is giving that, I could do a change of this tool set in another 4 days. So there are many advantages which comes into the real-time scenario if you implement the smart manufacturing. The first benefit I would always recommend or always suggest is it will eradicate the skill set of the users which they have been already laid with this conventional methodology. So as a definition, a smart manufacturing is the integration of advanced digital technology. For example, what is the advantage? If I wanted to compare it with the lathe, we do have all the, just imagine in a tooltip, I do have a 4-star sensor. It's a FTA sensor, which is completely used in different robotic segments or anything. So if the force or torque, especially the force, right? So especially the force which is in the tooltip, which is given with the manual feed rate is very higher, then it will give me that your feed rate is very higher, please reduce it. If I have a servo motor control, then it can manage accordingly that, okay, this is the feed rate which was given as an input by the user, so I should accordingly manage this as a feed rate. So a servo motor integrated with the 4-star sensor. So here I have added the 2 electronic systems to make this normal lathe machine into a smart lathe machine by just adding 4-star sensor and servo motors. So here we define this kind of change in equipment is called retrofitting the machines with the smart tools. So where and all you can use the smart manufacturing. So one is the production monitoring, because like in Indian industry mostly rely on larger volume of production. So you can just look into the complete production monitoring for a factory and quality. So if the production monitoring is efficiently done, then the quality is equivalently very good. And supply chain planning. So depends upon if the organization is working into the logistics in a larger volume, then the supply chain management and energy efficient. So whenever people work with high energy consuming equipments, so then energy management plays, and ultimately they do have ERP protocol. So smart manufacturing doesn't mean that you have to integrate all the 10 technology. Even if you add a small sensor to a conventional machine, and that also can act as a first layer of smart manufacturing. So this is just to tell about that these are the technologies which can make your conventional manufacturing procedures or conventional procedures into an industry 4.0 integrated procedures. So here majorly we can come across the sensors, which I said in the right example as a 4 torque sensors integrated into a tooltip of the carbide or like any kind of lead. And the digital twin, yes, of course we will be discussing much on this. Augmented reality, big data analytics, and then collaborative robots, industrial internet of things. So we'll be just discussing one by one. So here this is the major arena where we can utilize these kind of small technology changes in the different segments. So during the yeah. So, can you mute? Can you mute, please? Yeah, thank you. So there is an actual segments which we can manage in the industries is safety, operation, maintenance, quality, and training. Here during this presentation, I will be concentrating on what are the technologies that we work with the industries when it comes for safety, when it comes for maintenance, and when it comes for training. So I will be just discussing on where we are going to fit this industry 4.0 module or industry 4.0 first level of beginner steps into the conventional systems. Okay, so present technology in the global market, very simple. The innovative technologies are these 4. I would always tell artificial intelligence. Yes, I think all the mechanical professors will be for sure knowing about the terminologies, because it is coming up with a very faster demand, and mainly because of its use cases. And digital twin, IIoT, and spatial tech. So we defined this AR, VR, and MR as an spatial technologies. So that's what the spatial technology is. So fine. So coming into industry 4.0, I said, so we'll just have a small comparison between why industry 4.0 and what is the next level of industry 5.0. What is the difference between? Suppose if an industry is only focusing on automation and smart factories, then that comes under the segment as industry 4.0. Suppose, just imagine, I'm the robot. I'm going to do some pick and place operation. Just imagine this robot is capable of picking one object, and the human is capable to place his hand, or he is going to hold another one component. Very similar to a concept like everyone in the home used to have a coconut grinding machines. Sometimes the motor gets rotated, the person used to rotate the coconut here and there. It's a collaboration. A machine and a coconut grinder is getting collaborated. So very similar to concept. There are some places where the human and the robot or a machine in the industries has to collaborate. So this collaboration will be happening only if we have the right tools for example, I'll just tell, this is a simple concept. This coconut grinder as a concept, if I want to give a right force, right angle, I get the proper coconut peel, right? So this collaboration, so the system should understand what is the force, what is the torque that the person is going, and what is the safety feature. So everything comes into as a package, right? So if that is being done, then the human and the robot collaboration is that is what the people are mainly looking into the industry 5.0 technologies. And the technology, yes, it is, yes, AI, IoT, big data, digital twin, cobots. Cobots are nothing but, now whatever I explained in hand, right? If a robot does that, it is called collaborative robot. A robot with a collaborative nature is called a collaborative robot. So these are some of the example when it comes for human role, flexibility, what kind of flexibility that the people will be receiving on the back end. So main is, as I said, the first thing, if I wanted to touch into industry 5.0, it is obviously a cyber physical system. Yes, number 1. Number 2 is human machine collaboration. That is what the major demand for Industry 5.0, and it is lean and flexible production. To make it flexible production, during the last session, one professor, I guess, like they were asking a question: what is the role of a 3D printers in an Industry 4.0? Just to give a small insight on that, just imagine I have a component which has 4 parts. The 4 parts are going to have a different dimensioning, depends upon the customer's hyper personalization. So whenever the customer demands a request for procuring that product with his hyper personalization parameters, 3D printers will print every components accordingly. It's called 3D printing lakes. So they will print, and then robot go and pick every component from the 3D printers and assemble and send the products. So that is one of the best example for Industry 4.0 integrating with the 3D printers. So here I said about 4 things. One is hyper personalization, 3D printer laking profiles, we can manage it, and then AI suited designs. So these 3 things are majorly when it comes for Industry 4.0 if you want to integrate the 3D printers for the concepts. Okay, so now I believe like the faculties and the participants will be knowing about this terminology called IT and OT systems. So globally, any technology that comes into the picture is categorized into IT and OT. So IT is nothing but information technology. It's purely on data, bits, bytes, communication, data sending from one end to the other end. So everything is IT managed data. So only it focuses on communication, visualization, and AI. Whereas OT is the operational data. So as a mechanical people, we operate with machines, electronics, many kind of sensor devices. So anything that is going to control the physical world, we can categorize into operating system. So industry is mainly looking for this IT and OT convergence. So one of the best example is you could see a self-autonomous car. The self-autonomous car is one of the best example for IT OT integration. You have electric drive, you have complete sensors into the self-autonomous car, you have edge AI concepts to control your car. So these two are amalgamated to get an IT-OT convergence. So the proper terminology is called convergence of IT and OT terminology, IT and OT technologies. So that's it with this term. And the most common technology before AI was this IT-OT convergence, and now it is completely on AI. AI is the most demanded technological term because of its scalability, not because of the other things, because mainly of its scalability. Okay, and what does the IT OT system convergence is going to have? Now I'm going to relate the same with one of the factory. So OT system, for example, just imagine I have a factory. In that factory, I have a compressor, I have generators, I have machines. So all the machines are there. That is my operational systems. IT systems is all the data, all the machine data. It has sensors. All the sensors are connected towards the IT systems to maintain locally, and all the data is connected towards the edge systems. So edge system is at the edge. All the data are connected towards the edge, and from there it is being pushed towards the cloud. So the data can be used locally, or the data can be pushed to the cloud, depends upon the requirement for the customer. So we do maintain the industrial cloud, industrial based cloud softwares. So majorly we use AWS, we use GCP, Google Cloud Platform, and to make it more user friendly but high costly product is we work with PTC ThingWorks. So these are some of the products that we mainly work for this kind of industrial cloud. So there are different levels of segments layers have been. So the first one is we were talking about the sensors and actuator layer, hardware layer, and then the digital control systems and PLC and supervisory level. So we have seen that in Industry 3.0, these 3 levels have been already satisfied. All these 3 levels have been in the Industry 3.0. But now taking into this ERP level and taking into the cloud AI and taking into the data into the cloud interfaces, and that is where your Industry 4.0 is there. So it's very simple. If I wanted to touch Industry 4.0, my machine should have the complete control level and sensor integrated thing. So only then the Industry 4.0 is being applied. And the levels of digital maturity in manufacturing. So people always tell that we are in the integrated stage, we are in the connected stage. No, but still the people and most of the manufacturing companies are in the emergent stage. So the first is traditional stage, where they have a digital foundation, that is just connecting some basic level of sensor for notifying some information, just connecting some temperature sensors to tell that the temperature is this, connecting some digital pressure sensor to tell that the pressure value is beyond. And now if that is being connected to the ERP systems, and that is being connected to the control systems, and then that is your emergent stage. And with that emergent stage, we should have some kind of decision making algorithms. It is not AI algorithms, it is just a digital decision making algorithms. It's very simple concept called thresholding concepts. Typically people will know what is beyond this threshold, it is going to be unsafe condition, beyond this threshold is going to be safer condition. So if the people could able to attain this, so it is just an informed decision making. So that is the connected stage. So if we couldn't able to gain a value out of it, so even though after setting a threshold, it is not performing in a right manner, then we go for AI based advanced algorithms, which can fine tune automatically. So this integration stage is that AI integrated with your cyber physical systems, AI integrated with the physical systems. So that is what. And digital first stage, one of the best example I wanted to tell is recently, maybe in another 4 to 5 months earlier, you might have come across a news called dark factory from China. So a factory will be functioning without lights, all the systems are completely integrated, all the systems are completely sensor connected, all the data is being connected to the cloud, and it has its own AI embedded algorithm. If something goes wrong, then the lights switch on automatically, then only the human can go and check what is the problem. So, and there are some sophisticated algorithms which can fine tune the changes in errors to make this process continuously working for this production. So some of the mobile phone devices have been completely fabricated in dark factories in China. So there are some challenges in adapting this technologies as well. So as in technology trends, so first, as I said, industrial internet of things. Here you could see a dashboard. This is an exact dashboard that we are working with one of the client, which is India's prestigious client. So here, whatever you see is backend is a data. From data, from backend we collect all the data, and what you're seeing is called an customer experience center. And this is customer experience center, and it's also a customer control system. It is not very similar to the SCADA system. SCADA system will be having only one process. Here we take the command of whole factory. Here we take the command of even the whole city, right? How much of effective utilization that the energy is being consumed in the factory, every asset, do I need to do control parameters? So everything is monitored in the one experience center. So this is completely as in front end, we work with Unreal Engine, which is one of the gaming kind of platform as a front end. The back end is completely AWS, and from the factory, so we do have Siemens PLC and Siemens controller, and sometimes we work with Schneider controllers as well. So from to put it in the very clear perspective, mission is being controlled by Siemens PLC controller or Schneider PLC controller. From Siemens PLC controller, we mirror the data, push it to the cloud, we store the data, and we also do a data mirroring to our experience center. So this is an industrial internet of things concept. So it is completely acting as a bi-directional. From here I can stop any mission, from here I can take a control of any mission. So these bi-directional communication from the factory to the experience center can happen effectively. So this is what one of the basic which I was explaining about the industrial internet of things as a factory. Now Dubai city and many cities wanted to convert as a smart cities. We talk about a word called smart manufacturing. They are converting into smart cities. They monitor a whole city using this kind of dashboarding system. So just to give you one example on what is digital twin.
Digital twins.
Yes.
The innovation backbone of the future, delivering virtual representations of real-world products, systems, and cities. For example, the digital twin of an electric motor not only
can anyone just confirm me whether the audio is clear to you all, or is it just muted?
No, sir. Both the audio is visible. Audio and video are visible.
Okay.
only showcases form, but also analyzes functions, from the rotation of the shaft to thermal conductivity to data from sensors and beyond. What's more, The digital twin
Okay. Can you able to see this picture now?
So,
Yeah. So now what you're seeing is an digital replica of a motor. Maybe the past speaker also was explaining about the induction motor. Just imagine that this to be an induction motor. So now this induction motor is completely digital. It is not the real one. So digital twin, the first layer is called digital replica. So now imagine I have the complete 3D model of a motor.
continuously evolves, thanks to the flow of data, user experience feedback, and new input. And it's greatly impacting development, production, and operation. In development, a product's behavior can be simulated and tested long before a physical prototype has been built. Siemens utilized the digital twin to develop a world record-setting electric aircraft motor that not only weighs 50 kilograms, but is also 5 times more powerful than comparable electric motors. But it doesn't stop there. Digital twins also unleash the power of 3D printing. In a recent Siemens study for gas mixing systems, insights from the simulation of form and flow behavior were combined with generative algorithms. The result? A truly unique channel shape and configuration, one significantly more efficient than anything previously designed. Even entire factories down to individual machines can be simulated and tested. For instance, robots. It's difficult for them to perform milling tasks because large forces in the manufacturing process lead to inaccurate movements. But with the digital twin, the forces that push the robot away from the milling path can be calculated and compensated in real time, keeping the robot in its path. When it comes to operations, digital twins can compare the sensor data of a real point in real time with the simulation of its point. The availability of the point parallel to operations can be reliably predicted, and sudden disruptions become a thing of the past. But this is just the beginning, and Siemens is already driving the future. Merging digital twins with artificial intelligence allows computers to independently design advanced products. Siemens is realizing this potential right now with Californian startup Hackride, which aims to build customized
Okay. So I think the video was just to convey that Siemens as a product working on digital twin technology in a multiple area. You could, in a video, you could able to see an additive manufacturing as an demonstration. You could see an robot machining process as an application segment, and also you could see an railway track changing possibilities as an segment, and you could also see a simulation as an output, and also you could see an electronics as an application end. So this digital twin will be an futuristic technology, and even now some companies are working on that to create their own dedicated platform. So to put it in a simple context, what is the terminology called digital twin? Just imagine whatever you, since everyone are from mechanical background or some, we might have come across some any kind of 3D modeling softwares. So we used to design the components, correct, right? So whatever you have designed in the software, and that is called visual twin, VISUL, visual twin. It is a 3D model. It is not the replica of the real machine. Just imagine we have I have two assets. One is the real pump, and the right side is a digital pump. Okay, if I get all the live parameters of the motor and I connect all the live parameters into my visual model, then that becomes a digital twin. If I am not bringing the real data from the machine to my 3D data, 3D model, right? If I'm not bringing, then that still becomes a visual model. That's called visual twin. So digital twin is if I have any asset, if I have any mission, I need to take the physical parameters also. A parameter like vibration, a parameter like motor RPM, a parameter like temperature, a real parameter I take and I connect it to the digital model. So then that becomes your digital twin. So there are many misconceptions. Visual twin is completely different. Digital twin is completely different. So elements of digital twin, what are the elements it should be? Number one, you should have a physical equipment. If I wanted to work on digital twin, number one, I should have a physical equipment. For example, in this video, you could see an wind turbine. In the wind turbine, generator is a physical equipment. Number two is twin model. The twin model is nothing but the 3D CAD data, and also you could see there are many asset data, real-time operational data, and context data. So asset data is a basic 3D dimensions. Real-time data is at what speed the generator is working, and what is the vibration of the generator, and what is the temperature of the generator, and whether the oil viscosity in that generator is very good. So all the real-time operational data is connected to the twin data, and context data is nothing but your empirical model or your mathematical equation. So everything will be fed into the digital twin model. And third is the data sources. Now it is going to run its own AI algorithm. AI algorithm will run only with the help of the past data. So if I wanted to work on digital twin, it is not that directly we connect and start from the day one. No. First, we need to work on the visualization and acquisition layer. We need to collect the data, and we should create the positive condition and fail condition and negative conditions, so that we are optimizing the AI algorithms. So only then it gets saturated. So first thing is, every digital twin gets saturated mostly after 6 months or 7 months. Mostly depends upon the high level of volume of data and high level of empirical informations. And once I have everything, what is the advantages? I can tell to my operator that this wind turbine has to be maintained, or the maintenance person to go and do this maintenance process in another 20 days and 43 minutes. I can give you the pre-defined maintenance schedule for this wind turbine. It is not like an fixed maintenance. It is not like an preventive maintenance. It is a predictive maintenance. So if I want to attempt a predictive maintenance, then I should have a digital twin model also to understand what is the failure which is going to happen. So here, what will support that? Just imagine, I have found that there is only one problem, that I have to change the bearing. Then if my unexperienced person is going into the wind turbine, then he will be wearing the VR headset or AR headset or MR headset. Headset can be anything. He is wearing that, and it will give me the guided procedure. It will give me the guided procedures to. It will give me the guided procedures to tell which bearing I am supposed to change. So that is where the exact utilization of this AR, VR, and spatial technology getting connected with my digital twin model. So here AI will find the fault. AR, VR technology will tell how to solve that problem, how to do a maintenance activity for that problem. That is number one. Number two, it can also do a simulation run through. I can also just do a fast forward. What if the same asset performance is going to happen for the next 2 months? So I can fast and do a simulation in the AR, VR itself. So this is an overview of the complete digital twin. And also I will just explain with the other one different use cases for a mechanical people directly, if you really wanted to start with a digital twin. So this is one of the basic example for anyone to try the digital twin. Okay, so here what is happening is, you could see a mechanical component. It's just a weightlifting equipment, for example a crane or anything. So I have a real machine, and I have a digital model of the machine, where the stress and strain real-time data is connected to my 3D visualization software. So accordingly, with respect to my mathematics and real-time data, you could able to see the simulation. Okay, so now you could see there was an error stating that the warning was it was showing that the warning is mainly because of improper weight conditioning and position, the stress values being very higher. So, and then we can stop the machine. I'm just saving a huge cost for the company if something goes beyond some anomalies, and everything can be sorted out easily. And which link is getting higher stress due to this improper unloading and loading condition. So this is a 3D environment. It is not just a simulation platform that you do. Simulation is before whatever you wanted to fabricate. This is digital twin is after erection. So everything live data is connected to the twin model. So this is what I was mentioning about the twin model. The same you can also try for induction motors. The same you can try for pump. At the same you can try for compressors, which is already available in the most of the engineering colleges. So this is how the first level of digital twin is getting it started with. Okay, so the digital twin it has its own advantages and disadvantages. When disadvantage majorly it comes in terms of cost, and number two is when it comes for getting the proper mathematical equation behind the system, and how do you get the complete sensor feedback. So that is where the most important technologies when we wanted to get it, the digital twin question happens with. And maintenance, mostly digital twin is being used in maintenance because there are many uncertainties are in the manufacturing areas, and when it comes to machine anomalies, there are many things. So we should have the complete operational history. So that's what I said. Digital twin, if you wanted to start for a mission, you should have at least 4 months to 5 months of mission data, and it should be completely validated by the SMEs. So, and benefits, yes, of course, we can optimize the maintenance cycle. And one of the most major problem in the industry is scheduling the maintenance for the missions. So that is the most common problem. So, and there are types of twin. Please always think that it is not going to be an upper scale. You can also work in a different segments. You can also work on a small component twin also. It is not that you're going to take the whole process and converting into digital twin. No, it is not that demanded. You can also start with a component twinning, and after the component, they can work on this asset twin, and then it can create as a system. So this system is like controlling 4 to 5 aeroplanes. So asset is nothing but a one mission. Component is a motor, a mission, a complete system, and the whole system. So these are some of the types of twins we can work along to get it started. So as in professors, if you really wanted to start, as I said, work with the induction motors, compressors, or the pumps as a component twin. With that, if you could able to gain that, then try it for the mission. So for a development, for the deployment, you can. I would recommend you to directly get into AWS or like Microsoft Azure platform or GCP, Google Cloud, or any kind of industrial vendors. Like industrial vendors, I would recommend to go for PTC based ThingWorks. So the same kind of systems, digital twin. We have one common platform that anyone can start working on it. So the platform name is called NVIDIA Omniverse. NVIDIA Omniverse is the one platform where physical AI can be tested, simulated, and deployed. So it is one of the very good software, but it is very challenging to learn. Because why I tell the challenging is, to install that NVIDIA Omniverse, we need a higher end CPU configuration. So that CPU will be very high production GPUs requirement. So this is one of the videos just to tell how this NVIDIA Omniverse software can be used for anyone to work on first level of Industry 4.0 as a simulation software, and how to work on AI integrated with any machine assets. So this is the software called NVIDIA Omniverse.
The AI agents helping robots, workers, and infrastructure navigate unpredictable events in complex industrial spaces will be built and evaluated first in sophisticated digital twins. This Omniverse digital twin of a 100,000 square foot warehouse is operating as a simulation environment that integrates digital workers, AMRs running the NVIDIA Isaac Perceptor stack, centralized activity maps of the entire warehouse from 100 simulated ceiling mount cameras using NVIDIA Metropolis, and AMR route planning with NVIDIA cuOpt. Software in loop testing of NVIDIA Metropolis and ceiling mount cameras using.
Okay, so just to add few information to it, what you're seeing is not the real CCTV camera. It is a CCTV footage has been used as a multi-camera tracking, and every data of a human person's movement. And if any logistic, this complete workflow is explained using the logistic arena. If in one bay, if the boxes have been filled and there is an accident, then the remaining AMRs or the forklift handling humans will be annotated that you are not supposed to use this path, please use the some other path. Everything is triggered in a second itself. So that is the most important advantages when we're implementing this NVIDIA Omniverse into the system.
NVIDIA Metropolis and AMR route planning with NVIDIA cuOpt. Software in loop testing of AI agents in this physically accurate simulated environment enables us to evaluate and refine how the system adapts to real-world unpredictability. Here, an incident occurs along this AMR's planned route, blocking its path as it moves to pick up a pallet. NVIDIA Metropolis updates and sends a real-time occupancy map to cuOpt, where a new optimal route is calculated. The AMR is enabled to see around corners and improve its mission efficiency. With generative AI-powered Metropolis Vision Foundation models, operators can even ask questions using natural language. The visual model understands nuanced activity and can offer immediate insights to improve operations. All of the sensor data is created in simulation and passed to the real-time AI, running as NVIDIA Inference Microservices, or NIMs. And when the AI is ready to be deployed in the physical twin, the real warehouse, we connect Metropolis and Isaac NIMs to real sensors with the ability for continuous improvement of both the digital twin and the AI models.
Okay, so that was just a basic inputs on how this so one common software can be used for AI and robotics integration, AI with any kind of industry 4.0 or smart manufacturing. If you really wanted to try few things, that is one of the best software where we can download it at free of cost. Only the problem is we need to have a higher end GPU. That is the thing. And that software is capable for HIL and SIL simulation, hardware in loop simulation and software in loop simulation. For example, if I have a Siemens PLC with me, if I really wanted to check whether the Siemens PLC will run this complete factory without any kind of errors, I can create the virtual factory and the real PLC will be connected to the virtual factory and we can do the testing here. So that is called HIL simulation. The rest of the things are software in loop simulation. So that is, this is just to tell, this slide is just to tell about one of the product that we developed in collaboration with Bonfigli for one of the small proof of concept work. So this is just to tell about predictive maintenance for a ship turbine system, right? So this is one of the best use cases which was given as a problem statement by the Bonfigli. I'm not discussing much. So these are the parameters that we took as a temperature, pressure, and the common failure modes. How exactly our system works is we have a complete data of the compressor. We do have empirical data. We do have the past data of the same compressor which was running in the same ship for 10 years. And we created our GCP AI and ML algorithm. And finally, it will be connected to our XR visualization platform. For example, this is the workflow. First, we take the sensor data from the machine. Since we don't have ship or we don't do a real-time deployment, we take the data that is called, we create the data actually. And the next is the ML algorithms will be running behind and any changes with the real-time data. So the past data is the ML data and the real-time data will be fed along that. And then the XR visualization is nothing but the AR technology, which we can bring that whole compressor onto the floor. I will just showcase it and it will tell that the inlet pressure is 0.55, outlet pressure is 1. So any changes in the pressure, it will tell that you have to go and do the servicing for this component alone. So that is called the marine twin digital replica, maybe. So in this image, what you're seeing is we have bring that compressor onto the floor, right? So it's an AR technology. The same digital model will be overlaid onto the real ship compressor, I mean like turbine systems or a compressor. So that is where we can get all the annotated information virtually anywhere. So that is one of the best use case that we work. So due to time constraint, I will just push this some of the walkthrough example how anyone can start the digital twin. You can start with your CPU itself. With your present CPU as a hardware, you can take the CPU sensors. That is like the CPU has its own temperature sensor. CPU has its own fan controllers. So there are some state of values you can take from your CPU motherboard itself, and you can run your digital. So this is just to tell about how you can use your CPU itself as an mission or a asset to create your digital twin platform. So I'll just skip this slides. So this is one of the use cases where you use AI systems to measure the ergonomics for the employees. So this was done in Mandalika. It's a one company, and we do same kind of ergonomics kind of audits with BMW as well in the different parameters. Okay, this is just to tell about a few insights. Just imagine I have a camera system in my manufacturing plant. I'm talking about the safety now. If any person is not wearing the helmet, right? So my algorithm will tell that the person with all the body geometries, body motions, doesn't wear the helmet for this process. Then I will create a compliance report stating that this person is not wearing the helmet, this person is not wearing the mask, this person is not wearing the earplugs, this person is not wearing the goggles. So that compliance report can be instantly generated. Just imagine it is for one person, and now industry is working for setting up these kind of AI based vision monitoring system for more than 100, more than 1,000 employees using one or two dedicated cameras. This is one of the example when it comes for safety. This is also, again, yes, of course, this is also an industry 4.0 integration to safely monitor the employees rather than asking any one person or a supervisor to monitor those 1,000 employees. So there are different segmented areas where these kind of smart systems can be integrated. One of the best example is smart agriculture. I will just skip this. So this is what the predictive maintenance in manufacturing, which I was explaining, and that just imagine if a skilled can easily sort out what is the problem with the pump by just looking into few parameters, but an unskilled labor, if I wanted to deploy into that, so we are creating a system. So these kind of IoT sensors will help us to take the data from the pump, and using my AR technology, it will tell what is the problem onto the machine itself. I will just run through a small video. This is an XR technology which is how the pump and parameters can be used. So this is how we do. We have a tablet devices. We'll simply scan the floor. This scanning can be even done in the real factory also. The asset will come on the table itself. This is exactly 1:1 scaling, and you can also do scaling, rotate, and everything. If you use live annotation, now this video is not connected with the IoT data, right? This is just a visual twin. It is not a digital twin. It is visual twin. I am only seeing the component. These are fixed animation. Don't think that it is a real machine data. These are predefined animation. It is called visual twin. Whenever I have an IoT data connected to this digital model, only then that becomes a digital twin. Okay, so we can explore all the components. This will help the persons to check how to do the maintenance procedure for, just imagine, like it will have more than 300 components. So how to remove. So that's called SOPs, right? So standard operating procedures. In factories, we are converting SOPs, which is in the paper, into a digital SOPs using these AR technologies. So this is one of the basic workflow that we used it for Doosan robots, which is a South Korean robot, in a different manner. This is what I was talking about, digital SOPs. So step 1, so what you're supposed to do. Step 2, so every guidance will be properly giving annotations so that the people without the proper skill set can also operate the very high-end missions. So energy management, yes, of course. So the flow is very simple. Any kind of physical asset, connect to IoT, IIoT protocols, push it to the cloud. From the cloud, run through AI algorithms, and getting into this system using XR technology. So this is the basics of any kind of implementation for AI or any kind of this digital twin parameters for a smart manufacturing. So this also has smart manufacturing technology, which is in industry 4.0. So whenever you connect and sensors into a machine, then that becomes a smart manufacturing. If I wanted to make this as an intelligent manufacturing, then these kind of technologies will come into the play. So these are some of the use cases where you can try in different. So digital twin, I said no, digital twin for factories is one of the huge segment. Digital twin for construction industry, digital twin for smart cities. Government is working on digital twin for smart cities. So now in Chennai, Ananagar, you could see most of the CCTV footages have been automated for billings, right? If someone crosses a lane or any kind of improper methodologies being, I mean, like improper things are followed, then we get challans automated, right? So once these kind of systems have been integrated, then it is easy for the people to work on smart cities as a digital twin, because we have CCTV footage, all the data, and with that people can run the already existing AI algorithms. They can fast track the numbers, so people can easily track which vehicle number at presently in where it is running. So everything can be sorted out easily. So remote monitoring health, this is one of the greater benefit. Water, it is very simple effect, but it will save huge volume or sustainability. When it comes to sustainability as a major talk, the smart water management.
Back door.
So and IoT for water conservation, it is one of the most in-demanded projects you can assign for the students or anyone to start IoT with water conservation, or IoT and water conservation for a digital twin concepts, or for the pump, increasing the efficiency of the pump. So anything that matters, it will really help. And this is a condition-based monitoring for aviation industry, yes, but it has a different perspective, but the technology remains the same. So this is just to tell about this simple smart manufacturing. Doesn't mean that only the production. This smart manufacturing can also be coming into the picture for maintenance. The smart manufacturing can come into the picture for also safety, can also be used for training, right? So not only focusing on production of the equipments. So these are some of the companies who mainly work with these kind of digital twin platforms. So we closely work with Siemens and Schneider Electric for creating our own digital twin platform. Siemens also have their own digital twin platform called Accelerator, so which is commonly used in industries. So we are working on same kind of products. So I think this is the maybe a simplest way of explaining how this technology is being integrated in the industries, which is creating the business value, and also it is saving the huge cost in terms of ROI for the companies as well. So this is a simple presentation which I believe I've just given a few insights about what exactly this smart manufacturing and digital twin concepts, IoT integrations are stepping into the industries, and how people are adopting into it. So that's it from my side. If there is any further queries or any questions, I'm happy to discuss accordingly.
Thank you so much, sir. Participants, any queries, please post it in the chat box.
Is there any predictive software simulation tool available that we can analyze soil stability and geological condition to forecast sudden road subsidence or sinkhole formation? Okay, so just to answer this question, we don't have a ready-made packages for your domain, like construction, soil. So the soil mechanics is completely different categorization. We don't have any kind of standard software which is developed the soil mechanics as a package, as a library. But I would recommend you as a step-by-step procedure is first get a good Python developer, create your empirical, all your basics mechanics about the soil mechanics parameters, and this predictive can be done in the real time. First, you have to create your own simulation, or not the simulation, real-time rig, where you can add some small level of embedded sensors. you obviously, since you talk about soil, you will also know about the repose angle of soils and everything. So try to simulate the same kind of environment that you are talking about in the larger scale. Try to create this as a real-time asset, connect the embedded sensors, get the values, change the real-time, like the rain condition, water flow condition for this asset, this real-time situation, gather the data, and then only you can able to draw. So if it is a machine, I can directly tell that we have many softwares. If it is in construction industry, we do have softwares, but not for the requirement that you asked as in soil stability and the geological condition. Maybe for the geological condition, you get the parameters as an AI inputs from the different softwares. But for soil stability, you have to create your own miniaturized version of the whole concept what you're talking about. Okay. So, but once you create that, this can be utilized for the different segments. So we can create it, we can utilize it in the different arena only by changing the parameters. For every terrain condition, you don't need to simulate it. So that is why you're training your AI model generically, not utilizing the others model. Yes. So any other further questions?
Participants, any queries, please post.
Okay, so thank you. Thanks everyone. I could say like the participants are really passionate. Like, so all the 70 members have been completely into the session. So spending your time to just understand the terminologies, understand what exactly the industry 4.0 and smart manufacturing have been implemented in the industries, and just to understand that. So thanks everyone just for showcasing your patient and listening to the session till almost like it's almost nice. Thanks everyone. Thanks for your patience.
Good evening, everyone. On behalf of the organizing committee and all the participants, I take this opportunity to extend our heartfelt gratitude to Mr. Sridhar for delivering such an insightful and enriching session on IoT 4.2, Industry 4.0, and digital twin. Sir, your talk has not only deepened our understanding of the emerging trends in Industry 4.0, but also highlighted the transformative potential of IoT and digital twin. We sincerely thank you for taking time out of your busy schedule to be with us and for making this FDP session highly valuable. Once again, thank you, Mr. Sridhar, for your enlightening session. We look forward to more such interactions in the future. Thank you, sir.
Thank you. Thanks for organizing such a kind of FDP program. Thanks for the institution management and everyone. And thanks for inviting me to be a speaker. I feel like 1 hour I could just share whatever insights that I do have. Thanks a lot. Thanks everyone. Thanks participants for your patience in listening to the session. Thanks a lot.
Thank you, sir.
Thank you.